if you have any query, you can raise your hand and Vishal sir will answer your questions. Okay. I am clear. Am I clear, everyone? Hello.
Yeah,
Hello.
you are audible, sir.
Yeah. So I hope I'm clear. So Vishal, you can start.
Okay, sir.
Yeah.
Okay, first of all, very warm good afternoon to all of you. So, myself, Vishal Raut, I am actually a master trainer at ISI India Private Limited. So, today the session was what we are really going to do is designing the battery systems and electric mobility is concerned, right? So, basically, we're going to cover in this topic basically what are the see designing a battery system for e-mobility as far as two-wheeler, four-wheeler is concerned as uh, sir, actually, I'm again, not able to share the screen. Rajiv, sir, my voice is audible.
Just a second. I'm checking it.
Yeah.
Can you check now? Are you able to share?
Yeah, I can able. Is my screen is visible? I hope.
Yes.
So, in today's class, we'll basically going to understand designing of a battery system for an electric mobility or an electric vehicles is concerned. So, basically, we're going to cover this topic basic in three phases. Yeah, good afternoon to everyone. Basically, we're going to cover this topic into three phases. First of all, we're going to understand some of the basic things, right? Regarding the cell parameters and the chemistries. Then we can able to move to some other factors like if I'm not wrong, if we can able to move to the calculation parameters of that thing. Then we can move for a battery pack manufacturing sections where we're going to understand what are the various tests which is actually been performed as far as cell is been concerned in order to select the proper cell for the battery pack. Then we can directly move to spot weld the complete pack. Then we can integrate the battery management system to that particular pack, and then we are testing the cells in the testing the battery pack in the systems, right? So we'll more focus on the testing parameters, on the calculation parameters rather than chemical as well as the parametric calculations, because I hope in certain workshops we had also covered that parametric as well as the calculation, parametric as well as the chemistry part. Today's workshop is based on the designing part as well as the testing part of that particular thing, right? And at the end, we're going to understand what is the homologation process if you wanted to certify your particular battery pack for the process of utilizing that battery pack in electric vehicles. So what are the various processes actually been indulged in it? And as far as go-kart is been concerned, see, manufacturing a pack for an go-kart, manufacturing a pack for an electric vehicle is not that different apart from design. That in an electric vehicle, you have the larger space. In the go-kart, you have a compact space. So based on that, you have to, identify that designing thing. Main focus or main concern come if you wanted to manufacture a complete pack by yourself, you don't want to outsource it. So there is the process which you need to follow, right? Even if I'm not wrong, if you'll understand this process, you can able to start your startups and you can become an entrepreneur as well. So in this complete section, we're going to see and look into that particular thing that what industries are basically things so that they are able to manufacture a complete pack as far as designing is concerned. So let us move without any further delay. What exactly is the battery? That we all know it is an energy source, basically, right? So as far as IC engine is been concerned, the energy source is an engine. as far as electric vehicle is been concerned, the energy source is the battery. And battery is basically a device which can convert your chemical energy to the electrical energy. It will store the chemical energy and it will give the electrical energy once required, right? Again, if you wanted to charge, we can give them the electrical energy and then it will store that electrical energy in the form of chemical energy. And once you're going to discharge it, it will give that chemical energy in the form of electrical energy. So that is what about a battery has been concerned, right? So it is a direct power supply. It's a direct current source or a DC source is been there. And again, if I'm talking about why a battery is being utilized inside an electric vehicle, why cannot we go for capacitors? Why cannot we go for some other sources? We can even go for an inductors, capacitors again we can go for, or we can go for a super capacitors as well. Why we have been opting for a battery? See, battery is a portable device. Now you can say capacitor is again a portable device. We can portable it, but yes, capacitor is again a portable device. Battery is too, but capacitor is not meant for storing the energy for huge amount of time, and capacitor is not meant for storing the energy for larger amount of time. And that is the reason why battery is one of the device which is more portable as well as it is more convenient to be used inside an electric vehicle. That is the reason we are utilizing the battery pack inside it. But there is some research still going on such that we can able to manufacture energy storage device using a capacitor. But that research is actually working on, they are working on the ultra capacitors and the super capacitor side to make, along with integrating with the battery, so that the instead of giving complete load to the battery, we have some load diversion by the help of capacitor and super capacitor pack. But that is separate things and topic to be discussed. So what exactly do we mean by the battery pack? It is nothing but a combination of cell or a combination of a module, right? So what exactly is a cell, if I can let you know? Cell is that small electrical device where exactly the electrochemical reaction is going to take. Cell is that electrochemical device, right? If I wanted to sell you inside a battery pack the electrochemical reaction, where exactly the electrochemical reactions takes place, it is inside the cell. Like our body, every energy creation process is being happening inside the cell of our body. We have muscles, inside our muscles we have bloods, in the bloods we have cells, and inside that cells only our energy is being created inside a mitochondria. Likewise, cell is that basic unit of a complete battery pack where the actual electrochemical reaction is actually taking place. When cells are connected in series or in parallel, they led to the creation of a module, and when modules are connected in series and parallel, they led to the creation of a battery pack, right? So we'll understand the various approaches of manufacturing a battery pack for an electric vehicle, like cell to pack approach, like cell to module to pack approach, like cell to chassis approach. We're going to understand that, right? So evolution of a battery has been happened from 1800. A cell is being developed. A cell is nothing. It has been started from now. It has been started earlier in 1800 when the first cell is being invented by the scientist called as Alejandro Volta, and the name of that cell is a voltaic pile, which is there at 1800. Then the second cell, which is a rechargeable cell, the first rechargeable cell of the world, has been found out in 1859 by a scientist named Gaston Plante, which is a lead acid battery. And nowadays we are also utilizing the sealed lead acid battery, SLA battery. Okay, or we are also utilizing nowadays valve regulated, lead acid battery, VRLA, right? So we are all utilizing that thing. Then in 1866, Leclanche cell has been found out, which is again a primary kind of cell. Then we had going forward to find out a NICD. Then we had been go forward to find out the NIMH. Then we had go forward to find out the lithium-ion cells basically. And nowadays we have been working on the lithium-ion cell. And if I can tell you about the lithium-ion cell, it is for when multiple scientists like Goodenough, Sony, they had worked a lot on this lithium-ion cell in an earlier version. And first company who had utilized the lithium-ion cell is the Soviets, who has commercialized the lithium-ion. And then we saw that how the lithium-ion cell has been revolutionized. And now we are utilizing the lithium-ion cell, and we are used to take the courses of a lithium-ion battery pack manufacturing for that work, right? So this is a global market demand for an lithium cell has been concerned. Just to go for a basics has been concerned, you can see the secondary battery is having a higher global, means the rechargeable battery had grabbed the market significantly. Even we can see the growth in terms of primary cells as well, but primary cells are not that much of popular. as far as growth is been concerned. A lot of secondary cells are being there. You can, and out of this lot of secondary cell, you will find lithium ion is at the top of the market. Again, cells are again further classified into primary and secondary. Primary is a rechargeable one, secondary is a non-rechargeable one. Primary has been used for some lower current carrying appliances. Secondary is actually been utilized for higher current carrying appliances. So there it is being utilized. And lithium ion is a part and parcel of a secondary cells. Primary batteries, if I'm talking about AA, AAA batteries, like Lange cells, alkaline batteries, they are the part and parcel of the primary batteries, right? Then again, on the basis of internal constructions of the cell are been further classified into dry, wet, and solid state. I'm going a bit fast because our main intention is to cover something else where we wanted to depart our more time over there. I'm going such that we had already covered, so you can have a brush up on your previous knowledge, right? So electrolyte composition based on what kind of electrolyte we had been injected inside a particular cell. Based on that, the cell are divided into dry, which is a dry or paste-like electrolyte, right? Second is a wet state battery. All the lithium-ion batteries which we are utilizing, it is maybe LFP cell, it is maybe NMC cell, they are all the wet state batteries. And we had third type of batteries has been concerned is the solid state batteries, which is nowadays is on research. Solid state battery yet not invented properly, but yes, some of the mobile batteries are made up of a solid, but again, they are not that feasible, and still the research is being going on. Still, they are not been commercialized. Again, they are of the research. So once it will be researched properly, you get to know what exactly the thing there. But wet state battery are more prone to explosions or fire risk. The dry state batteries are lesser prone to explosion, fire risk, and solid state batteries are, negligible amount of risk in terms of explosion, right? Because here the electrolyte itself acts as a separator, but in other cases, electrolyte instead of acting as a separator, they will acting as a buffer if some nail penetration or if some outer radiation is being happened, right? Then we have based on an electric vehicles, our battery is further classified into traction battery pack and auxiliary battery pack. Basically, traction battery pack is those battery pack which we are utilizing as far as vehicle propulsion unit is been concerned. And in today's video, we'll more focus on this traction battery pack. And auxiliary battery pack is a pack where we are more focused on giving power to the auxiliary equipments. Auxiliary equipments, when I'm talking about those equipments who are work on the low voltage supply like 12 volt, and if you are going into the Tata vehicles, they are working on 24 volt system. But most of the traction battery pack had been started from 48 as far as EP is been concerned. It is goes to 60, then 72, then 100 likewise. It is going in that fashion, right? So minimum voltage for an electric vehicle to be operated on is 48 volt as far as traction battery is been concerned. Then it is 60, 72, and likewise it can, right? And auxiliary battery pack, it will go from 12 to 24 volt. In that case, I had only saw Tatas have utilizing 24 volt systems, basically in the commercial vehicles, but majority of the vehicle, you can take an example of an MG, they are utilizing a 12 volt system as far as auxiliary battery pack is concerned. But yes, that battery pack capacity is bit high, right? So components of a particular cell is anode, cathode, electrolyte, separator, and electrode. We had already understand in our previous workshops, right? So anode is something where the oxidation takes place. Cathode is something where the reductions takes place. Then we have electrolyte. Electrolyte is basically a kind of substance to which what I mean to say, through which it will only allow the flow of ions, but it will not going to allow the flow of electrons, basically, right? So it will physically going to separate the two electrodes, right? So it will only going to allow the flow of ions. And for the purpose of safety, we are placing a separator in between. So again, the cell manufacturing process is itself is a bigger thing, that in what ratio we have to mix which chemicals so that we can prepare a proper lithium-ion cell. Then again, cell testing and formation process, which I thought we had covered in the previous workshops. So we cannot cover that. So this is the basic, basically lead acid battery have a negative electrode. These are all the negative electrode of every cells, and these are all the positive electrode of every cells. You can see lead acid battery negative is made up of lead, positive is made up of lead dioxide, And nickel cadmium negative is made up of cadmium, positive is made up of nickel oxyhydroxide metal hydride, it is MH, and nickel oxyhydride is positive electrode. Metal hydride cells are is actually made up of AB5 or AB2 classifications category. AB5, A stands for a rare earth element which will work to store the hydrogen, and B will going to stabilize that, which we had already covered, right? And lithium ion battery, in the negative electrode we are utilizing the graphite, and in the positive electrode we are utilizing the lithium metal oxide, which is LiMo, right? And based on what metal we will going to use, right? On the basis of that only we will going to segregate the systems. If we're going to use the iron, then we can call that particular battery as a lithium iron phosphate or lithium ferrophosphate. If we're going to use the nickel, manganese, and cobalt in ratio like 1:1:1 or 8:1:1, then we can call them as a nickel, manganese, cobalt cell, or in short form, we can call them as an NMC cell, right? So, so these are something, right? So, give me a moment, everyone. Is this record session later? Ram, we will discuss it after the session because recording is there, but it is available to or not, I don't know. But at the end of the session, you will get to. Great. So this is something which is used for an oxidizing agent is concerned, and positive and negative here. Let us move forward. So you can find these are the multiple parameters which will tell you that why we wanted to use the lithium ion cells rather than the lead acid, nickel cadmium, and nickel metal hydride. You can able to see this table, and in the left hand side you have a multiple parameters basically. So first parameter is the cell voltage. If I'm talking about the lead acid battery, it is going to give you a 2 volt, nickel cadmium 1.2 volt, NiMH 1.2 volt, and again lithium will going to give you 2.4 3.8 volt. That means if you are preparing a 72 volt battery pack, so in that 72 volt battery pack, you have to use more lead acid battery, more nickel cadmium battery, and more nickel metal hydride battery, but you have to use lesser lithium ion, right? So voltage is exactly an electrical pressure basically of one single cell. So higher voltage it itself tells you fewer cells is actually been required, and wiring will be bit less, and the battery pack weight will also going to be reduced, as well as your design will also going to be simple, right? Then if I'm talking about second thing, which is the three things which is very, very important, that is specific energy, energy density, and power density. Basically, specific energy tells you how much watt-hour of energy you can able to store in per kg of weight, and energy density and power density will tells you how much energy and how much energy density means how much energy you can store in per liter of volume, and power density means how much power you can deliver in 1 liter of volume, basically, right? So if you can able to see lithium ion having the highest value among all this, right? So that is the reason why lithium ion will take lesser weight and lesser space to give the same amount of voltage what nickel metal hydride, nickel cadmium, and lead acid battery can. And very small energy density, power density is being performed by lead acid battery. That is the reason why if we're going to use a lead acid battery inside an electric vehicle, so the vehicle will be a bit heavier, and if we're going to use the lithium ion battery pack, the vehicle will be a bit lesser, right? So lead acid battery are a bit heavier, which will make your vehicle heavy, which will again going to consume a lot of space inside your vehicles. So this battery utilization will again going to consume a lot of space. So that is the reason why these battery packs are not preferable as far as commercial vehicle is concerned, because they won't give that much amount of range, and they were very heavy and very spacious, right? Then we'll come to the next thing, which is nothing but called to be as a C rate. So basically C rate is exactly stands for the maximum discharge rate, which is most important part of the complete cell is concerned, right? Understand, if you'll understand the C rate, then you can perform any test on the cells basically. First, just you need some setup with you, then you can able to perform any test on the cells. Yeah, you can able to perform any test on the cells basically, right? So here if I'm talking about maximum C rate is being written 5 to 10 for lead acid, for nickel cadmium it is 20 C, for NiMH it is 15 C, for battery pack like lithium ion it is nothing but called to be as a ATC. ATC is actually telling you the maximum discharge, it is not a charging C rate, but charging C rate is much lower. Basically, if I'm talking about discharging C rate, it can be go up to 80C. Even I had taken some cells like if there is an LiPo battery, lithium polymer battery. Over there, the C rate comes on 120C as right. But charging C rate is bit less. It is 2C to 5C only because charging too fast can able to cause the lithium plating, overheating, and it can able to create a dendrite creation inside the lithium ion. That is the reason why charging the always you will find in the specification sheet of the cell you can they will give you the you can able to discharge that particular cell at 1C and 2C, but you can charge it at 0.5C to 1C. You cannot charge it at 2C because if you're going to charge it at 2C, then there will be the high chances that inside your cell there must be the lithium plating may happen, or your cell may overheat, or dendrite may cause, which will again lead to the creation of a thermal runaway, right? And why lithium ion can do 80C, but why cannot lead acid and nickel cadmium and nickel metal hydride, why cannot they can, or why cannot lead acid can go up to 80C? Because see, inside a lithium ion, if I can talk about, lithium ion have a very lesser internal resistance. That is the reason why ions can see. For example, if you have a lesser internal resistance, then you can able to transport from internally, right? So your ions can easily transport internally. But if your internal resistance is too high, so your ions will take time to transport, right? So that is the reason why the lithium ions can move swiftly compared to the ions which is moved inside a lead acid battery, right? And again, if I'm talking about the lithium ion battery, they have a better electrode kinetics than the lead acid battery, right? And they have lower voltage stack basically, and they can able to have a higher conductivity. That is the reason why a lithium ion can able to discharge at 80C rate rather than if I'm talking about the lead acid, they cannot able to discharge at 8 basically, right? So this is all about the C rate. If I can tell you about from the useful capacity point of view, again, lithium ion is going far ahead from all other chemistries. Charging efficiency, lithium ion is stopping. Cell discharge, again, the lithium ion is stopping, right? So everywhere you will see the lithium ion is something which is stop the thing, right? And temperature range, again, the lithium ion is having a higher operating temperature range. Cycle life, again, the lithium ion having a more than 2000 and 2000 cycle range. And lithium ion memory effect, it is not there in lithium ion. Basically, memory effect will not there in lithium ion basically. And microcycle tolerance, it is not there for any cells. What do we understand with the term called as microcycle tolerance? We are never charging from 0 to 100 and discharging from 100 to 0. We are charging, let us suppose 0 to 100, then we'll discharge up to 80, then again we are charging up to 100, then we discharge up to 65, then again we are charging up to 80. So this kind of cycle is called as a microcycles, right? So this microcycles, if it will going to continue in all cell, that will going to deteriorate this battery pack as well. And last one is the robustness. See, lead acid, nickel cadmium, nickel metal hydride are robust in the normal condition. They don't require any kind of battery management. But this lithium ion battery is highly required of a battery management system, without which it will not going to work properly. And that is the reason why BMS, and electronics company are having a higher part as far as EV, right? So these are the multiple cathode material which is being utilized as far as lithium is been concerned. You can able to use an LCO, you can able to use NMC, you can able to use NCA, you can able to use LFP, LMO, LNMO, right? So basically, as far as electric vehicle is just give me a moment. Yeah, as far as lithium ion has been concerned, we are more focused on, as far as lithium ion has been concerned, we are more focused on utilizing this LM. Yeah, we are more focused on utilizing these cells basically. Nickel, lithium ferrophosphate and NMC. These are the two cells which is mostly utilizable as far as EV is been concerned, or even your mobile phones has been concerned, these are being utilizing. But earlier version of mobile phones are utilizing this LCO cells. But now LCO cells are being detonized, right? And LCO is more used with, and every NMC, LFP, you will going to see the specification in the forward slides or in the forwarding slides. But majority of an electric vehicle is utilizing these two chemistry. And as far as Indian structure has been concerned, we are more focused on the lithium and pyrophosphate, chemistry. And these are all the things which is being written, that lithium pyrophosphate is an olivine structure, and they have iron and phosphate as its main constituent, and they will give you something which is very important: excellent thermal stability and long cycle life. And that is the reason why they are more as far as EV is concerned. But whenever you'll go to the foreign companies, or whenever you'll go to the US and that countries, you will find this particular cell is more focused. Why this NMC cell is more present over there? Because NMC cell have something called to be as a balanced energy and power, and they have a good lifespan. Again, see, LFP cell will not properly work in the cold environment, right? If you have a cell tester, we had a cell tester, we try to charge and discharge the LFP cell at very cold temperature, or nearly around 10 degree or 5 degrees Celsius, or even -8, 7 degrees Celsius inside an thermal chamber. So LFP cell are reluctant basically. They will show more internal resistance in order to charge and discharge basically, right? And below certain point, they were very reluctant to charge, or they were very reluctant to discharge as well, right? We have to forcefully indulge huge amount of current, then only it will going to discharge, right? And in a practical vehicle, we cannot indulge forcefully a huge amount of current, else our vehicle will getting heated, or our battery will getting heated, or it might happen the battery will getting damaged, right? So that is the reason why lithium pyrophosphate, you won't find it will be perfectly working on the cold region. But NMC will be perfectly work on the cold region, and LFP require a preheating before. If let us suppose if Tesla is utilizing an LFP cell inside its vehicle, so it required to preheat them. So that is the reason, if you look on the Tesla vehicle, they have something called to be superchargers. That superchargers, if at the winter times, they used to first charge it, overcharge the complete vehicle battery pack, and then the vehicle battery pack will generate certain heat, and that heat is very useful for the LFP in the cold environment. Then it will come to a stable temperature range, and then it will be run. Else it will not run. Else your BMS will not run, and if it will directly go and sit inside the vehicle and turn on the ignition, it will never happen. So LFP has some disadvantages, but at hot weather, the LFP works better. And if you can able to do the nail penetration test in NMC and LFP, NMC will going to explode in the nail penetration test. The temperature will going to rise, linearly the temperature will going to shoot up. But in LFP, your temperature won't able to shoot up. That is the reason why the company called as BYD, they are working on the blade batteries. I hope you all had understood what exactly is the blade battery. They are working something called to be as a blade battery. So that is the reason the blade battery is actually been utilized this particular chemistry only, this LFP chemistry, because LFP is something which is more utilizable and more thermal. Then we'll go for an anode material basically, guys. So anode material, if I'm talking about, they are made, majority of the cells are utilizing graphite as an anode material, right? Amorphous carbon is also sometimes used as an anode material, and silicon graphite composite, which is under research nowadays. Graphite have some characteristics, like if the lithium ion will go inside a graphite volume will be changed by 10% only, right? This is the chemical point of view if I'm talking about. But silicon, if we'll only use the silicon will be changed in volume will be 270%. And that is the reason we are not utilizing silicon. But silicon has some excellent tendency to store more lithium than the graphite. And that is the reason why we will take this graphite and silicon composite, where we will get the advantages of storing more electron and lesser volume will be changed because of the graphite, right? Pure silicon anode is not been used. Nano silicon we are utilizing, it has not been used basically. LTO is being used as well, and tin-based anode is still on research. And I never saw utilizing this thing, but LTO is being utilized. But LTO is being only utilized with LMO. If LMO is the cathode, then only we can use then LTO, it will going to give you the 5 volt, right? So Cattle is a company who had manufacturing this LPO battery as well, right? So electrolyte is basically made up of LiPF6 lithium hexafluorophosphate, which is LiPF6. This is nothing but the lithium solvent, electrolyte solvent, which is majority being made up of this. And if I'm talking about the solute, solute is made up of DMC and ethylene. Actually, what is, guys, I request not to write anything in the screen. Yeah. EC plus DMC is actually been utilized as a as a solute basically, and we are sorry, yeah, as a solvent. I'm extremely sorry. It will be utilized as a solvent. Give me a moment. It is being utilized as a solvent, right? And inside this solvent, we are adding LiPF6 salt basically, right? In the 1:1 ratio, right? So then only we can able to make it. And why we are utilizing EC and DMC? Because EC will going to create something called as SEI layer, solid electrolyte interface layer. But EC is more viscous, and but EC is something called as not that much of conductive, and that is the reason why we are adding DMC with it. And again, there is another reason. EC will be there in the solid form in 36 degrees Celsius, right? So, but room temperature is 25 degrees Celsius. So they are present in a solid. You know, reduce this, temperature to, nearly around -6 degrees Celsius, -7 degrees Celsius, likely, right? And that is the reason why we are utilizing EC and DMC solution, right? Else we can only utilize EC, it will be happen, but EC is not good at room temperature, it is in the solid form, then that is the reason we have to add DMC not to convert them into the liquid form, right? So I hope this thing is been clear. And in some electrodes, we are utilizing gel-based electrolyte. I had told you lithium polymer batteries, lithium LiPo batteries. If you have ever worked on, death race, ever work on in your BTech times, if you had made your death race course, or what I mean to say, your line followers, or obstacle avoidance go at your BTech times, so you might have utilizing the LiPo batteries basically. So they are the gel-based electrolyte. I told you solid state electrolyte is still on research, and ionic electrolyte, these all are an ionic electrolyte. So this is not a separate electrolyte. Basically, this all are an ionic electrolyte. And again, there is some other advanced research is still going on, but I will tell you, there is an instance which will going to come sooner than later, that this battery, this electrolyte will going to famous, right? But it is not now, it is having some time. And again, separator is made up of polyethylene, polypropylene material. Then we can use the PE, PP and tri-layer separator with that. We can also go for a ceramic coated separator, where we have a polyethylene, polypropylene layer, and over there we're going to add some ceramic coated, right? So what will be happen in this ceramic layer? Basically, we're going to coat them with a ceramic separator. So due to the dendrite creation, actually what is dendrite, guys? Let us suppose this is 2 electrode. So if the lithium has been unevenly coated over one electrode, so it will be going to extend from here, and slowly it will be going to puncture the separator. Yeah, any doubts anyone have? Anyone have any doubts? Sorry, I'm not able to listen. Someone has unmuted himself. Fine. So it will going to puncture this separator, and it will going to touch this electrode. So this is the major cause of fires in lithium-ion cells. So dendrite formation. If we're going to use the ceramic separator, dendrite formation is reduced. Then again, glass fiber separator is again, it is on the specialized industrial batteries are utilizing glass fiber separator. But what is the disadvantages? It is a brittle structure, right? Means if your cell falls, if your cell is being utilized for the static purposes, not for a dynamic purposes, it is good. But if glass fiber separator will be used inside an EV, and if your EV will go with rough terrains, bumpers, ulcers, and potholes, so ultimately vibration will going to happen onto the battery, and it might happen the glass separator will break, right? So this is all about the chemistry. Let us move quickly and swiftly towards the technical aspects of manufacturing and a vehicle battery pack basically. So if I'm talking about the approaches to manufacture a pack, so these are the three approaches basically we follow as far as EV is been concerned. First approach is nothing but called to be as a cell to pack approach, right? In the cell to pack approach, we are utilizing a cell to directly manufacture a pack, and then we are utilizing inside a vehicle. Then we have something called as cell to module approach. So if I'm talking about cell to module approach, it is something where we are manufacturing a module from the multiple cells, and multiple modules are connected together to manufacture a complete pack. So this is how the pack has been looking like. And then we have something called as cell to chassis approach. Here we are not utilizing any pack, or here we are not utilizing any module in between. Just we do simply connect the cells in series and parallel, and we are embedded them above the chassis. So you can see here we had not prepared any module. Here we had not prepared any kind of pack. We had just made a chassis, and on that chassis only we had spread this particular thing. I will let you know that I had seen majority of golf carts, even go karts, which is utilizing this cell to chassis approach as right. So if I'm talking about what is cell to pack approach, cells are integratedly directly into the battery pack without any kind of intermediate modules like cell to module approach basically. What is the advantages of utilizing the cell to pack approach? First is higher space utilization. Means the cell to module to pack, it will going to utilize more space, but cell to pack will going to utilize lesser space. Only 40 to 50% of space utilization will going to happen. And cell to pack is also called to be as a CTP. That's why if I'm letting, if I'll tell you CTP, so don't get confused on what is CTP. This is cell to pack approach basically, right? Sir, what is the real difference between cell and pack and cell and module? I told you, right? Cell is that smaller device where exactly the electrochemical reaction is taking place, right? So if inside a cell an electrochemical reaction will take place, so cell will going to generate a voltage of 3.2 volt or 6 ampere hour. Likewise, it will going to generate a voltage, but whether that 3.2 volt is sufficient or it is suffice to run my vehicle, answer is no. How come I can able to run a huge vehicle with 3.2 volt? I cannot run. So I need to manufacture a complete thing. So that is the reason why I am connecting the cells in series, so to increase the voltage. And if I wanted to connect them in a parallel, I wanted to increase the capacity of that particular cell. So let us suppose one cell can able to generate 3.2 volt, 15 cells. If I am going to connect a string of 15 cells, let us suppose 15 cells are connected in a series, and one cell can able to generate 3.2 volt. How much voltage I am getting? 48 volt. Now 48 volt is very enough for driving the vehicle, right? So that is cell where exactly the electrochemical reactions takes place, and from them we are manufacturing the pack, right? But there is an intermediate thing which is called as module, and that we are reading that what are the various approaches generally the companies or generally the manufacturers are following. Right. So first approach is a cell to pack approach. Basically, it is a traditional method which is utilized to basically it will only use 40 to 50% of space basically. And cell to pack means more active material is fit inside the same volume. And again, the cell to pack have higher energy density basically. Higher energy density. They don't will have a lower energy density. More cells are being fit. Pack energy density will going to improve, and it will going to improve the energy density by 10 to 20%, right? It will going to improve the space utilization by 60 to 67%. It will going to improve the energy utilization by 10 to 20%, right? And if I'm talking about weight, so generally, no module frames are being used basically. So if we are having a module, then we have to create a module K6. We have to use another holders for the module. Then module have their own thermal chambers and all those things. So that is the reason if you're not utilizing any module, so aluminum requirement is less. Fasteners which is being required to pack those module will getting deleted, and connectors which is required to connect each module with another, that will also going to delete it. So connectors weight, fasteners weight, extra aluminum weight will going to reduce, right? In case of increasing the capacity, the battery will be going to connect it in a parallel. We're going to discuss that, Ram, in the further section, right? In the further section, not the further slide, we're going to discuss. Right? So again, if we're utilizing this cell to pack approach, our manufacturing complexity will going to reduce, right? If because cell to pack is generally utilizing a fewer component, but if I'm wanting the cell to module, you want to prepare a module from the multiple cell, then you have to prepare another module and again another module, then you have to combine all the modules. So the cost will be very higher in CMP approach, but in CTP approach, the cost will be lesser, the complexity will be lesser, and you will going to connect the cells in series and parallel, and you're going to use the spot welding for that. So welding points will going to reduce. But in case of cell to module to pack, the welding points are very, very higher. And failure point in cell to pack will be lesser, but failure point in cell to module to pack will be very, very high, right? So that is something. But what is we had saw the advantageous side of the cell to pack, right? It is not like, sir, cell to pack is a godlike structure and CMP is not a godlike structure, it is a devil structure. No. Cell to pack have something called Tobias. I will explain you, Shlok, I will explain you in the further what is the advantages of the CMP. We'll going one by one so that you can have understanding on it, right? So what is the difficulties and technical challenge what cell to pack approaches will be having? That is thermal management difficulty, because cells are densely packed. So heat removal.
This meeting is being recorded.
So heat removal is very, very harder. So it is need that we need a liquid cooling plates. Then we need to have a thermal interface material, and we can use this particular thing in the CFD thermal optimization in order to understand that what is there. But implementing any kind of thermal.
The recording has stopped.
With this particular pack is very, very difficult as. Then second is the serviceability will be reduced. In the traditional pack, let us suppose if this is the approach in the cell to module, you will find one thing. Let us suppose if this module is being damaged, so these two are okay. So we can only go and check this particular module. We don't have to disconnect this module, right? But here, if this cell is being damaged, we have to take all the battery pack, then we have to remove all the spot welding, and again, that is serviceability is more expensive in this particular approaches. And in here we can able to replace the faulty module, then it will be fine. We can just have a faulty module and we can replace it. But here we have to take the complete pack outside. We have to again replace this faulty cell. Faulty, if we're going to remove this particular cell and if we're going to add a faulty cell, just we have to add a connector only, right? We don't have to add any kind of cells. But here we have to remove this spot welding, we have to remove these holders, we have to remove this cell, we have to insert the cell. Then again we have to do the spot welding. Again we have to add this particular connectors. Again we have to add a BMS, sensing wires over here, and a lot of things is being there, right? So that is the reason why cell to pack, entire pack often need to be repair and replacement. If one cell getting damaged, so entire pack is often needs repair and replacement, because no service company will going to change your one faulty cells. How do you think, even if you're going to become a manufacturer of a cell, you will never say your customers that I will going to replace one cell as well, right? You will take the price of replacing the whole pack if it is go away from the warranty period, right? Then third is the structural load on cells, basically, right? Without module casing, cell will experiencing a huge amount of vibration, shock, mechanical stress directly. That is the reason that is why we need a structural adhesive. We need to form an encapsulations. We need to form a compression system such that vibration, shock, and mechanically stress will not going to impact the cell to pack approach directly, right? So if I can talk about the BYD blade batteries, that is a real life example where we are actually manufacturing cell to pack approach, right? So LFP blade cell are directly been integrated from cell to pack. They are not forming any kind of module in between. Then we have another kind of vehicle which is nothing but called to be a CATL CTP 3.0, right? So this is nothing but CATL CTP 3.0, which is actually been utilized the cell to pack approach, but they are utilizing it using some kind of cooling integration. They integrate the cooling system. They are not utilizing any blade batteries, just they are utilizing a cooling integration, and they optimize the structure. So this is what is called to be as a cell to pack approach, right? And I had what exactly is cell to module and module to pack approach basically. So basically, module will simplify the manufacturing process. Module will simplify the testing process. Module will simplify the maintenance process. Basically, that is the reason why majority of the cars will be go from cell to module pack. And again, if we are integrating a battery, just for example, if you have an idea that let us suppose in a vehicle, if you are utilizing 1,000 cells, managing 1,000 cell by a single BMS is a very difficult, right? So that is the reason why what the four-wheelers are doing, they're attaching an AFE cards with this particular module. This AFE cards is called to be as analog front end cards, right? AFE cards, which we are calling. And this AFE cards is actually been connected to the battery management system, the main BMS, or we can call to be as some other BMS, which has been connected over here. So this AFE cards is actually responsible for managing each module, and for the complete battery pack management is done by the BMS. So this is a more precise approach. Like in case of your own state, CM is sitting on the top of the state. Below CM, there are multiple ministries come. That ministries is being represented by some of the IS level ministers basically. Then under that ministers, every department has been given with an IS level secretaries who are actually forming the complete policies for the complete structure. Then below that ISS, every district that come, and inside that district have own IAS, right? So every district IAS is actually take a report, and inside the every district IAS there are block divisional officers will become BDO. Likewise, the things will become, and similar things will be happening over here, which is nothing but the centralization of this, right? So that is why cell to module pack has been approached by multiple vehicle manufacturers, right? So that is, I told you here, it is easier to be serviceable. Here we can able to implement a thermal management system, and we can able to better give the thermal isolations. If one module over it, then thermal propagation is easier to control over here. But in this case, you cannot able to control. If one cell will be over it, the whole pack will going to be over it. It is flexible. This approach is very flexible, right? Because some module can be used across multiple vehicle having different capacity, right? But there is some technical disadvantages, guys. This will going to unevenly added the weight onto the vehicle, because every module have their own aluminum casing. They have their own thermal management system. They have their own connection. So they will going to add certain weight onto the vehicle. That's why they have a lower energy density if I'm comparing it with the cell to pack approach. And here we'll require an additional components, like we have to require an additional bus bar, additional boards, additional connectors, additional module frame, additional cooling interface, which will again going to increase the components. Again, the weight of this particular thing is like higher, but it is still used in certain EVs like commercial EV, older EV platform again is utilizing this thing. Service-oriented EVs are also utilizing this thing. Like if I'm talking about Tesla Model S and X, they are utilizing a module which is based on the cylindrical architecture. Mahindra Trio and older Indian EV platforms, they are often use the modular pack design. Even the Tata Tiago is utilizing the modular pack design. Then we have something called to be as a newly developed cell to chassis approach, which is very important. And cell to chassis, or it is called to be as a CTC. CTC is not stands for cost to company, it is cell to chassis. Right, CTC approach, right? Just give me a moment. AFE card is also AFE card has been present in the BMS itself. I had not add that particular image, but I will showcase you at that. I will showcase you the AFE cards. Fine. So cell to chassis, if I'm talking about, it is one of the most advanced architecture. Basically, a battery become a part of the structure itself. See. In CTP approach, battery pack is still a separate unit, but in CTC approach, battery itself become a structural member of the vehicle. If you wanted to remove the battery, you have to remove the vehicle as well, right? So if let us suppose if pack is being faulted, so someone will change your pack and it will going to add another pack to your particular vehicle. But if in CTC approach, cell to chassis approach, if your pack has been faulted, then you have to place your vehicle over there. Nobody can able to give you another pack for utilization, right? But the technical advantages which will come in the cell to chassis approach, there will be the maximum space utilization may happen. because almost entire floor become in battery structures where more cell can able to fit. And the weight reduction is very, very massive, right? There is a separate pack casing, there is a separate cross member, then there is a separate reinforced structure, which is actually been reduced basically. And that is the reason why weight is actually been reduced, right? So vehicle, if weight will be reduced, then vehicle will be lighter. Then they have higher torsional rigidity. That means battery will be act like a stressed structural member. And if you're going to use this particular cell to chassis approach, it will going to improve your chassis stiffness, it will going to improve your handling, it will going to improve your crash performance as well. And generally this kind of approach is having a lower center of gravity because battery has been integrated into the floor, and which improve the stability, cornering and rollover resistance basically, right? So but there is a huge engineering challenge inside is, if the crash damage of battery will be happen, then repair become extremely difficult in that case, because battery is an ice chassis structure, and if something will be damaged inside your chassis, you have to replace a complete thing also. So again, replacement is a huge challenge. Then thermal challenge has been there because it need an advanced cooling channels, because it has been connected to the cell chassis, so we don't have any other structure. So advanced cooling channels are being required, which is a part and parcel of the chassis itself. Then structural thermal interface material need to be properly decided, and fire propagation barriers is also need to be properly decided, else this will be the very and because of that only it is very complex as far as thermal challenges is concerned, right? So Tesla in certain vehicles is utilizing structural battery pack. There is a company, Chinese company called as BYD Seal. I'm talking about BYD Seal. They are again utilizing this cell to pack approach. Then Cattle Bedrock. They are also utilizing this cell to chassis approach, right? So if I'm comparing this cell to pack, they have a medium energy density. Cell to pack have higher energy density, and cell to chassis have a very higher energy density. And again, cell to module to pack have higher weight, cell to pack have lower weight, and cell to chassis is the very, very lowest, right? So cost of cell to module to pack is higher, cell to pack is lower, and cell to chassis is further optimized basically. But manufacturing complexity is more in cell to chassis. It is a bit high in cell to pack, and it is very lesser in cell to modular. So this is the fundamental relationship between that. If I'm talking about Indian Electric go-karts or Formula Student CV, they are somewhere utilizing cell to pack approach. Some of them are also utilizing cell to module to pack approach. But I had also seen some of the go-karts they are also had utilized, they are not used for the racing purposes, just they are manufactured by certain colleges to showcase that the go-kart can be also undergo cell to chassis approach, right? But racing students or racing teams cannot go for this cell to chassis because your module, because every time you require a repair if you are running your vehicle at very, very high speed. So repairability will be again a concern if you're going to use the cell to chassis, and if your chassis will be damaged somehow, you need to replace the complete pack, right? Then quick replacement won't be happening in case of racing is been concerned. In the racing, your quick replacement is very, very important. And quick debugging or easy debugging is also not able to happen in case of cell to chassis approach, right? And cell to chassis is again very, very expensive. Those who are working on go-karts, it is highly complex, and it is difficult for student level manufacturing. So that is the reason majority of them, I had seen these two approaches. And if there is need to replace the battery and removable battery, then most of the go-karts is going for this cell to pack approach. Nobody will mostly go on this cell to module to pack. But this thing is important. Okay, which type is high performance car? High performance car is utilizing two types. One is CMP and CPC, right? Competitions don't mention to use CMP configuration. Yeah, definitely they will mention CMP because that is one of the things which is more important, which is morely. If you will personally ask me, I will go for a CMP approach. rather than go for CTP and CTC. Because if I'll go for an CMP approach, it is good for me as far as serviceability is been concerned. Because I am a student, I cannot pour a lakhs of rupees in servicing if I'll go for a cell to pack and cell to GC approach. I need a proper serviceability for which CMP is most utilizable. Right, which architecture has easier serviceability? Definitely, CMP have an easier serviceability compared to CTC and CMP. So let us move forward. Yeah, it is okay. No worries on it. It is okay. I had seen many vehicles utilizing CMP approach. But again, there is some rules, laws has been written. So you have to go through the rule books as well, right? So that is not if I'm saying it is approachable or it is doing, there is rule book for every go-kart range. So you can go through that rule books, whether they are allowing or not. Based on that, you can able to go for it, right? Majority I had saw they are going to go for a cell to pack, right? And because it is easier to manufacture rather than and lesser amount of I had go for a cell to module to pack skin. Okay, I'm moving forward. So those who wanted to manufacture a battery pack, basically, so what they yeah. So those who wanted to manufacture a complete battery pack, so now we're going to discuss those things in detail that how we can able to manufacture a battery pack as far as our EVs has been concerned. So these are the certain steps basically. See, manufacturing of a battery pack is not a process of, it's not a smaller process. It's consisting of huge stages. It is not like we'll go to the market, we will purchase certain cells, we will connect them in a series and parallel, then we will utilize inside a vehicle. If we'll do that, we will end up with some kind of accident someday. We will end up with a lot of breakdowns. We will run off some. A moment. What dead battery architectures look like? See, dead battery is something which is, it is consisting of an LFP chemistry zone, right? But it is the design of the blade battery is in such a way that the heat is being dissipating in the surface. Although LFP is good for heat dissipation and heat accumulations, but the design of an LFP blade battery is just like a blade structure. It is vertically long. It is not an horizontal structure. It is a vertically long structure. So likewise, it is a blade-like position. That's why we are calling it as a blade battery, right? Fine. Let us move to other sections, right? So see, that is not I'm saying that is never happened, that if you will have to do the testing elements, if you have wanted to manufacture a battery pack for your vehicle, then you can just do one thing. You can you can purchase the cell from the market. You can just assemble the cells in series and parallel, and you can use it inside a vehicle. That phenomenon will never happen. You have to undergo certain test process, basically, right? What kind of test process will undergo? Because see, whenever we are taking, for example, if take we as a humans, let us suppose if we'll have some health checkup. Means generally we used to do the health checkup to test what is our diabetic level, what is our blood sugar level, what is our blood pressure, what is the number of RBC count in our blood cells. All those multiple tests you are performing so that you can able to see whether you are, see, even if I'm healthier, sometime I used to perform the test. Why? Because if something will be there, it will be came out, then accordingly I will take the medications, right? Likewise, in order to, if we're going to purchase the cell, we don't know how that cell is being manufactured. We only have a specification sheet of the cell, and based on that specification sheet of the cell, we have to test the cell. Then based on that testing, we will decide certain parameters, and based on that, we can able to select the cell for our purposes. Right? So that is the reason why I have to follow certain steps which require a cell testing. And once the cell is been connected and manufactured into a battery pack, then again the battery pack need to be undergo certain tests such that whatever we had been desired to manufacture a battery pack, whether that particular battery pack is being manufactured or not, whether that capacity is being acquired by that battery pack or not, whether that voltage is being acquired by battery pack or not, we need to test. And that is the reason we are following certain process. In that process, the first step which we are following is the cell grading. Second step which we are following is the cell sorting. Third step is a thermal management integration. Fourth step is the battery pack assembling. Then we'll do the testing and quality control. Then finally, we are assembling the cell into and installation inside a vehicle. So we'll go one by one to the process basically. So first process is nothing but called to be as a cell grading. Okay, so basically what we are intended to do in cell grading, let us suppose we have a lot of cells, let us suppose we have 500 cells, and out of those 500 cells, we have to only select the 15 cells, right? So I have to test, for example, I am a manufacturer of a cell, I had manufactured the cell and you are the purchaser of that cell, you are the consumer of that cell. You can take the cells from me and if you wanted to manufacture it in the battery pack. I am telling you, why? This is the cell, take me this cell from me, right? And this cell will going to give you 6 ampere hour and it is having a 3.2 volt voltage and it will going to give you the 6 ampere hour. But now the question comes whether you will believe me. You will say you might be telling a false thing. There might be, it is not 6 ampere hour, it might be a 5 ampere hour, it might be 4.5 ampere hour, it might be 5.5 ampere hour. So we will definitely going to test the cell. Again, I will not going to give you the cell in 15 and 20. If you are an industrial person, I will going to give you the cell in 1000, 2000 and in the bulk, lakhs of cell will going to be sold to you. Right. Now the question comes, we will not going to use the lakhs of cell in the single day. Right. In the single day, certain amount of cell is being used and certain amount of cell is being stored for 1 month, for 2 months. Likewise, the cell is being stored for the multiple times in a particular environment. So definitely the cell may degrade it. So if it is something called to be as the cell grading testing. And in the cell grading, my intention is to test the cell capacity such that when, for example, if I have a cell, one cell is of 5 ampere, one cell, I am claiming that my cell is 6 ampere hour, right? And if one cell is 6 ampere hour, if I wanted to select a 15 cell, from that 500 cells, I am going to select those 15 cell which is having a 6 ampere hour capacity. If I am going to take a cell, one of 6 ampere hour, one of 5.9 ampere hour, one of 5.8 ampere hour, okay, fine, 5.9, 5.8 will be fineable. But it is having a 0.1 differences, so it will be fineable. If I take one cell of 6 ampere hour, if I will take another cell of 5.5 ampere hour, if I will take another cell of 4.5 ampere hour, and I will measure and I will manufacture a battery pack. So whether you thought that battery pack will going to sustain, answer is no. Whenever you're going to test that battery pack in the field or you're going to install that battery pack in the vehicle, your battery pack will going to fail because they have a different capacity. So your battery pack will not going to give you an intended range. Your battery pack will not going to give you that amount of capacity what it intended to. So that is the reason why we have to properly check the capacity and the voltage of the cell. And for that, we are doing a test which is nothing but called to be as a cell grading. That is the very first test in the complete assembly line of a battery pack manufacturing we are doing. And we are generally classifying the batteries on the 4 grade. One is A grade cell, which is an highest quality cell, and they will going to give you a performance, good, excellent performance, and their reliability is also high. And that is the reason why they are typically used for electric vehicles, aerospace, premium electronics on that. Then we have something called as B grade cell, which is nothing but a medium quality cell, where their performance is acceptable. You can use them in the moderate reliability factors, but they're typically utilizable in the power banks and low cost energy storage system. Here it is being written as CS. Then we have a C grade cell. It is a very, very poor grade cell or a low grade cells, right? And it is performance is very, very poor and reliability it will not going to sustain morely. And again, the reliability is again having certain issue. And their typical usage will be on the low cost product refurbishing basically. So they are not being used for the EV premium activities or the premium applications. Then we have D grade cell, which is nothing but called to be as a rejected cell. Means these are the cell which has never been utilized for any purposes, and these are mostly unsafe and failed cell, and they are used for the recycling only, and they are very low cell. So I had properly see that if the manufacturer if we'll go to the mandi, sabji mandi, if we'll go into the sabji mandi, those who are taking the sabji from the, for example, you are purchasing a potato. So there is a wholesaler who are sitting with a potato. He will have a sack of potato, and inside that sack, if it is 10 kilo potato is being there. So out of that 10 kilo, we cannot say 10 kilo is the fresh potato. Out of that, 500 grams or something will be the poor potato, right? Which we need to throw it out. But he had paid the money for that. Likewise, if you purchase a bulk amount of cells, so definitely out of certain cells, some cells are being damaged. And that is the reason why you have to test the cell in order to understand which cell is perfectly fine for manufacturing process, right? Then you can see if you are manufacturing a 72 volt 60 ampere hour battery pack and you are utilizing a lithium ferrophosphate cell. Everywhere we are going to use two chemistry of a lithium ion. One is LFP, one is NMC. Why we are going to use an LFP? Why we are going to use an NMC? Because these are the cell which is mostly utilizable as an EV is been concerned. So if you are utilizing 3.2 volt and 6 ampere hour battery, 6 ampere hour cell to manufacture 72 volt and 60 ampere hour battery pack, then for grade A, you have to select 5940 mAh to 6060 mAh, right? It is typically called to be as a 5.9 mAh to 6 mAh, right? That is called to be as a grade A cell where your tolerance band is plus minus 1% or plus minus 0.1. Right? Then we have something called to be as a grade B cell. Grade B cell is something, comes under the category of 5.8 ampere hour to 5.9 ampere hour. And grade C cell is something which is below 5.8 ampere hour and which is not recommended for high load, and it is basically not recommended for proper use. Right? So this is for the LFP cell basically. Does refurbished laptop phones? No, not like that. Refurbished laptop phones are utilizing the A grade cells or B grade cells. They are not refurbished. See, those cells actually not C grade cells is never being utilized in anywhere because it is high chances that they will catch fire or they won't give you the intended range or performance. Again, the refurbished laptop is again utilizing a cells which is of A grade and B grade. But C grade cell, majority of them, they are being utilized for, you can say the second end. For example, if you don't want, let us suppose if you go to somewhere and A grade cell and B grade cell cost you higher, so you can opt for a C grade cell. That will be workable. But again, if you'll ask me, basically C grade cell is again not utilizable at anywhere, right? But again, refurbished laptop and iPhones are utilizing some electronic components which is refurbished, and that is the reason they are called refurbished. There is a grading machine slope. I will at the end of this PPT, I will again share my screen to showcase you how the cells are being graded. At the end, I will tell you, I will let you know there are the machine specific machines. And in the lab, I will showcase you that for the better understanding. Fantastic. Let us move further. If you are utilizing the same pack 72 volt 60 ampere hour, but this time you are utilized the NMC. Sorry guys, here there is a typo error. It is not an LFP cell, it is an NMC cell, nickel manganese cobalt cell. And nickel manganese cobalt, if I'll tell you the rating, or if I'll tell you the what exactly is the cell rating, it will going to give you the 3.6 volt and 2.6 ampere hour. This is nothing but the rated capacity on rated voltage and capacity which is been given by the customer or which is given by the manufacturer. If you wanted to test the cell and if the cell will be come with 2.58 Ah to 2.62 Ah, it is comes under the A grade cell. If the cell will come to 2.55 Ah to 2.57 Ah, it is come under B grade cell. And if it is lesser than 2.54, it is come under the C grade cell. And this cell is not being utilized. So don't mix this C grade cell with the 72 volt battery pack, right? And it is used for mid-tier applications for an energy storage. And the grade A cells is being used for high demand pack like electric vehicles, right? So we can use like that. Fine. Let's move forward. So this is a cell grading machine, guys. This is an industrial grade cell grading machine. So a lot of, you can see these are the channels. These are the channels which is being placed here. Right? This is where the cell are actually been placed, and there is a system where the already parameters has been coded. So based on that, they will going to charge and discharge the cell. Then based on that, the capacity will going to showcase it. And those cell which is fall under A grade capacity, you can remove it from there and you can use as the grade cell grading. So this is one kind of cell grading machine, which is an industrial grade cell grading machine, which is used in the bigger industries. And there is a smaller cell grading machine is also utilizable as far as lab is concerned. It is 8-channel cell grading machine, 4-channel cell grading machine, 6-channel cell grading machine. So in the lab there, with the ISI India facility. Yeah, any doubts? Yeah, any doubts anyone have? So in the facility where I'm currently present, there we have 8-channel cell grading machine. I will showcase you the interface of that. Then we have something called to be as a cell sorting, guys, right? So cell sorting is one of the second factor. Means first we're going to grade the cell, second we're going to sort the cell. So cell sorting is one of the most critical process in the lithium-ion battery pack manufacturing. Even though cell are manufactured in the same factory and the same production line, no two cells are perfectly identical, right? They always have a small variation, like their variation in the capacity, in their internal resistance, in their voltage, in their self-discharge rate, in their impedance value, in their thermal behavior. So before assembling a battery pack, a manufacturer will going to test and match the similar cell together, basically. Right now, the question comes, sir, why the cell sorting is necessary? In EV battery packs, 100 or 1000 of cells are connected together. Now imagine if one weak cell exists among the strong cells, entire pack configurations is getting affected. Right? Simple, if I'm talking about, there is a relay race team. If 9 runners are fast, but if you are a member of 10, 9 were fast and 1 will run slow, so entire team performance will be limited by the weakest runner. That is how the battery pack behaves similar, right? And if the, yeah, any doubts anyone have? Anyone have any doubts? Mahaling, Dattatreya, Masal, have you? Yeah, guys, please unmute yourself. It will create an hindrance basically. If anyone have any doubt, you can just raise your hands, or you can just do let me know in the chat box basically. Right at the end, once we'll be free from the thing, you can directly contact with me, whatever. Right? So yeah, where we are, see, cell sorting is happening because of pack imbalance basically. Suppose one cell has 3 Ah capacity, another has a 2.5 Ah capacity. So during discharging, weaker cell will be empties completely and voltage will be dropped faster basically. See, every time someone will going to say that we will going to do the cell grading and we are going to do the cell sorting, you will able to find that in the cell grading also we are testing the capacity, and in the cell sorting somewhere they are saying that they are testing the capacity. See, cell grading and cell testing, these are something which is nothing but called to be as closely equal, basically, right? But in the cell grading, we are more focused on capacity testing. In cell sorting, we are more focused on internal resistance testing, right? So we are more focused on internal resistance testing, where we are intended to see that what is exactly the internal resistance of a particular cell. If you are manufacturing a battery pack, your internal resistance won't go beyond 30 milliampere hour of a particular cell, right? So your internal resistance must be between, in order to check the cell internal resistance. For example, a particular cell having an internal resistance of 8 milliohm and another cell is having an internal resistance of 9 milliohm. So 9 milliohm is higher. So if you're going to pump a 1 ampere current from the 9 milliohm internal resistance cell, and the same 1 ampere current will be passed on from the 8 milliampere hour internal resistance cell. So the 9 milliampere will going to heat faster because its resistance is increases. 1 into 9 is 9 watt of heat it will going to reduce, it will going to release. And if I'm talking about, if I'm going to pass 1 ampere of current, if I'm going to pass 1 ampere of current with 8 milliohm or 8 ohm, let us suppose, and it thing. So how much amount of watt it will going to give? 8 watt, right? And if the same 1 ampere will be goes from 9 ohm internal resistance, so it will going to give you the 9 watt. So you can find here the heat is been higher and here the heat is been lower. right? So that is our intended to test that if this unequal heating will be happen, that will be differ in case of basically where we are following the cell to pack approach. There, testing there, cooling the particular cell will be very, very different. How we can able to differentially cool this cell and this cell? We cannot. That is the reason why we have to properly check the internal resistance. And in the cell sorting, we are intended to test the internal resistance, all right? And we are basically test the internal resistance by two methods. One is AC impedance method, and second one is the DCIR method, which is the direct current internal resistance, right? Yeah. There is a tolerance allowed variance in MAH for cell compared to the standard cell. I'm not getting this question, Ram. Can you please elaborate your question? Please, can you elaborate your question? How to check the internal resistance of the cell at all?
Vishal, are you there?
हाँ सर, मेरी आवाज आ रही है आपको? हेलो,
हाँ आ रही
Is
है,
there voice?
अब आ रही है.
हाँ, एक्चुअली यहाँ पे पावर कट हो गया तो थोड़ा फेज वगैरह के चलते, सो आई एम शेयरिंग माय स्क्रीन अगेन. Yeah, is my screen is visible to all of you?
Yes.
Okay. Fine. Okay, guys. There might be means I will be rejoining from the internet because there is a phase issue in the center. So the electrician has came to repair that phase one. So that is the reason why power has been cut. So internet is not available. So I'm joining from my mobile hotspot. So if the light will come, I will rejoin. Means I will again switch my internet. So just hang on there. Nobody will left, right? Fine. So in that case, I told you about the cell sorting machine. Basically, we are intended to calculate the internal resistance in the cell sorting parameters, because cell sorting is generally we had did the capacity testing in the earlier phases. Here we are generally used to test the cell sorting parameters, the internal resistance parameter. And based on the similar internal resistance with a tolerance value of 1%, we are sorting the cell. And if I can talk about, this is the cell sorting machine, how it has been looking like. It is an industrial grade cell sorting machine. You can say there are a lot of channels in this. So every means this is for lower, cell internal resistance. Likewise, different internal resistance will going to be sorted over here. And they will again going to be graded properly as well, right? So this sorting machine is also going to test the capacity, and then it will going to throw the cells inside these channels. You are watching this particular side. Here you will going to store the cells. The cells are being stacked over here, and slowly it will going to dissipate themselves to these particular channels in a slow fashion. So this is one kind of cell sorting machine, right? So you just, I hope it has been clear to you, the cell sorting process. Once the capacity has been tested, once the cell sorting has been tested, then we can go for battery pack assembly, because out of that 500 cell, we had successfully connected the 15 cells, right? Because if you wanted to manufacture let us suppose if I will say, right, for example, Just give me a moment. Let me create another slide so that it will be visible to you. Let us suppose if you wanted to manufacture a 48 volt and 60 ampere hour battery pack, right? And if you have a particular cell, there is a cell which is having 3.2 volt and 6 ampere hour. Let us suppose 3.2 volt, 6 ampere hour. This is a one cell rating, right? This is called to ampere hour is nothing but called to as a capacity which is represented by Q, and voltage is nothing but called as it is the voltage of the cell, right? Let us suppose if you wanted to increase the voltage, keeping the capacity constant, then you have to connect the cells in series. Again, I'm reiterating, if you want to increase the cell voltage, keeping the capacity constant, then you have to connect the cells in series. If you want to increase the capacity, keeping the voltage constant, then you have to connect the cells in parallel, right? But here what is happening? Here we have 3.2 volt each cell, 6 ampere hour. Here we want 48 volt, that means voltage is increasing. Here we want 60 ampere hour, that means capacity is also going to increasing. So we have to connect the cells in series and parallel. Now the question comes, sir, how many cells we need to connect in series? How many cells? Right. So that how many cells need to be connected in series and parallel? That is nothing but called to be as a configuration. That is nothing but called to be as a cell configuration. So if someone will ask you that what is the cell configuration, you have to simply say that how many cells need to be connected in a series and in parallel. So let us suppose you have 48 volt battery pack and you have 3.2 volt cell capacity, cell voltage. Then if you wanted to measure how many cells need to be connected in a series, so you have to divide 48 by 3.2. So what will become 48 divided by 3.2? It will become nearly around 15. So 15 cells need to be connected in series. So 15S. Now the question comes, how many cells connected in a parallel? Similarly, 60 ampere hour is our requirement, and each cell will going to give us 6 ampere hour. So it is 10. So 10 cells need to be connected in what? Parallel. If you want to increase the capacity, you have to connect the cells in parallel. If you wanted to increase the series or increase the voltage, you have to connect them in a series. So basically the cell configuration is 15S 10P. Now the question comes, sir, how many number of cell we want? Means if 15 cells connected in series, 10 cell connected in parallel. So likewise, how many cell we want such that it can able to give us the complete thing, right? That is nothing but we have to multiply 15 into 10. Number of cells connected in series into number of cells connected in parallel, which is 1. So totally you have to select 150 cells. That means if you have 500 cells, out of that 500 cells, you have to select 150 cells. You have to select 150 cells, right? So you have to select 150 cells. So 150 cells need to be selected by you, and then only you can able to manufacture a 48 volt and 60 ampere hour battery. Is this thing is clear to all of you? I hope this connections has been clear to all of you. Okay, fine. Sorry. Fine. I hope this thing is clear to all of you. Let us move to next thing, that how to connect a cell. So you can see this, these are the holders which is being present over here, and this is nothing but the cell, right? So this is called to be as the positive side of the cell. This is called to be as the negative side of the cell. So how are you going to connect a cell in series and parallel? So one cell you have to connect in positive, negative, second it will be in this fashion. So if you wanted to connect them in a parallel, so how are you going to connect? Just give me a moment, let me stop the pen. You're going to connect, if you wanted to connect the cells in series, so this is nothing but the series connection, upper 2 cell, then bottom 2 cell is when connected. Just give me a moment, guys. Let me change the color of the pen. It's visible. Yeah. Upper 2 you have to connect it in series, then bottom 2 you have to connect it in series likewise. Then this 2, then this 2, then this 2. How you are going to connect them? You are going to connect them utilizing a nickel strips. This 2, then these 2 cells, then these 2 cells, then these 2 cells, then these two cells, then these two cells, then here you will going to get these two cells, right? So here you are going to get positive, one positive, and from here you are going to get one negative pair from here, right? So this is nothing but 15 cells which are connected in series. So they will going to give, if you will check your multimeter over here, you're going to get a 15 volt DC, sorry, 48 volt DC, right? Because 15 cells are connected in series. So likewise, you have to create another layer, likewise, another 15 cells. This is another layer. Whatever the same thing you have been done over here, you have to connect another layer. Likewise, you have to connect another layer. Same, this kind of arrangement you have to did like this. But in this way, how many parallel path you can go? 10 parallel path. 10 parallel path, right? And you have to connect the same thing. And then you have to connect these 10 path in parallel, 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 right? And again, from the bottom also you have to connect. So from the bottom again, this parallel, from the bottom again, this is parallel. Like you can see here, if this is the positive side, so below side is the negative. So negative will look like this, positive will look like this. So positive will be connected by a single nickel strip, like this. Single nickel strip, and negative is again connected by a single nickel strip. Yeah, is it been clear to all of you? Right. So just give me a moment. Anyone have any doubt? Chat box. Make calculation in 500 number of cells and selecting. See what I am saying, Ram. See, I am saying you have 500 cells. And you don't know how, because you have a total number of 500 cells, right? I'm saying you can take, you have 1,000 cells. You can have 1,000 cells, right? But you wanted to select 150 cells for the purpose of your pack because you wanted to manufacture a 48 volt and 30 and 60 ampere hour pack, right? So you have 1,000 cells. Out of that 1,000 cell, you have to select 150 cells. And in order to select 150 cell, what we have to do? We have to use something called as cell grading, something called as cell sorting, right? So by a cell grading, cell sorting, we have to select 150 cell from this 1,000 cell. Then we can able to connect them in the series and parallel connection. Is this thing is clear to you? Now, had you have any doubt why 150 cells is being required? Because we have to connect 15 cells in series, we have to connect 10 cells in parallel. And that is the reason how many number of cells are being required. 15 multiplied by 10, it is 150 cells. Is it clear? Right? So that is not 500 cells and 150. That is, we have might be 1,000 cells. We might be 2,000 cells. But out of that, we need a 150 best cell such that if I will manufacture a battery pack, that pack will be sustained last long. Right? Fine. Let me remove this thing. So this is how the cylinder, see, we can manufacture a pack utilizing a cylindrical cell. So cylindrical done by pneumatic spot welding, or we have electrical spot welding. But if I'm talking about the another type of spot welding, it is called to be as a laser advanced welding, which is being utilized for applications of an bigger pack is been like if I'm talking about the Tata Tiago battery pack. So there the spot welding has been done utilizing the laser welding. But if I'm talking about the normal packs, which is being utilized by the local manufacturers, general spot welding is being done. But again, the local manufacturers is also utilizing the laser welding, right? So laser welding is more accurate and it is more computerized, but spot welding may be manual or it may be automatic as well, right? So, but if I'm talking about the prismatic cells, so this is another kind of form factor the cell is being present. So prismatic cells will connected using a bus bar. You can see this is the bus bar. This is nothing but called to be as the bus bars. right? So prismatic cells need to be collected or need to be, you know what I mean to say, prismatic cells need to be calculated utilizing the bus bars. So, right, so these bus bars is again made up of copper, or they are again made up of nickel as well, right? So you can see they are being bolted, right? So there is no need of any kind of, connections. See, that was depend upon your pack to pack approach, basically. At the end, I will showcase you or share you that thickness sheet as well, that what you have to use. But again, that will depend upon pack to pack. I will showcase you to look at the end of the session, right? It is there. Fine. So bus bar, copper bars, nickel strips, you can use to connect the prismatic cells in series, basically. So these are series connections. And if you do the parallel connection, this is nothing but the parallel connection. You can see, right, how the cells are being connected in a parallel. So the same thing is being happened. The only thing, the prismatic cells are in square shape, but the cylindrical shape are in the cylindrical shape. Once you add, this is the spot welding machine, guys. You can see this is the spot welding machine, how the spot welding has been done. So this is one kind of spot welding machine. This is the platform. And these, you can see, these are the electrodes. These are called to be as the electrodes, right? And these electrodes are being pneumatically powered. This is basically a pneumatical spot welding machine. You can see this is the pressure gauge which is coming. So you will have a foot pedal. If you will press the foot pedal with your leg or with your toe, this will come down and it will going to touch with this battery and it will going to spot weld the tip. Just you have to place the nickel strip above it. Just you have to place the nickel strip above it. Right. So you can see this is the spot welding, how it has been done, and this is the lab where our students are performing the spot welding. Right. So so this is the this is the pneumatically powered spot welding. So this is the lab where I'm currently there. So this is our students are performing the spot welding, and you can see they are actually wearing all the safety kits. Basically, they are having a quick jacket, shield, and the gloves. Because see, spot welding can able to ignite the spark, right? So you have to properly spot weld the thing, basically. Because if you're not going to, you have to properly select the current, you have to properly select the welding time based on the material thickness. Else what will be happen, the battery means it will going to puncture the battery. Here while doing the spot welding, because they are in the learning phase, they had punctured certain kind of batteries, right? How to say, okay, does weld quality, that is laser or manual welding machine affect? Yes, definitely that is affecting the performance of the battery pack. Weld quality is highly affecting the performance of the battery pack. I will tell you whenever we're going to learn the CV testing machines over there, I will tell you why we are utilizing the CV testing machines, CCD testing machine. I will tell you over there why it is required, CCD testing machine. And every industries and every one have their own CCD testing machine who will going to check this weld quality. If the weld quality is not good, they will going to give it. Right here, for example, these candidates are doing, as they are not that much of professional, so definitely their weld quality is not that good. You can just see from here, the weld quality is not that good. The welding is going upward over here and here, but they are learning, right? So it is fine for them to understand the basic thing, right? But quality of a weld affects significantly your pack. Right. So, further, right. So next, once the pack has been connected in a series and parallel, then we have to check the tensile strength of the cell. For example, if you can see over here, if we're going to connect the cell in the this particular series and parallel fashion, and if I take a plier and if I remove this particular thing, so this will be removable. If small bending and twisting force happen, this may come out. So we have to check whether properly the spot welding has been happened or not, and that is the reason why we're utilizing something called as tensile strength tester, right? So spot welding is very important in critical factor in joining process, because cells are connected using the nickel strips, copper bus bars, aluminum taps. Right now, let us suppose if the weld quality is weak and if weld is not properly happened, the connections may fail during the vibrations and during the current flow, during the heating, during the vehicle movement, and that is why the tensile strength testing is important. So tensile strength testing is the mechanical quality inspection process, basically. In the industry, it has been following, where the weld joints are being pulled using the controlled force, using the failure, using the controlled force until the failure occurs, right? Basically, if I'm talking about you are manufacturing a cell, then your cell can able to take able to withstand the force of 8 to 10 kgs, right? There is a well, you can see over here. This is nothing but called to be as a tensile strength tester. If this tensile strength is being pulling this, so we're going to apply 10 kg, and if 10 to 12, if at 10 to 12 kg it is opening, then it is fine. It is good enough for the purposes, right? But if at lower weight or lower, pulling force or pulling kgs, it will be going to separate it, then your tensile strength is not there. So the purpose of the check is just to check weld joint is properly strengthened or not, or bond quality is properly strengthened or not, or it is mechanically reliable or not, and the durability of welded battery connections. We are utilizing this particular test. Right? Machine, right? See guys, CCD inspection machine, if I'm talking about, it is actually stands for, guys, just give me a moment, let me switch to my, just give me a moment, let me switch to my another network. Yeah, it is on the different switch. Just give me a moment, guys, just give me a moment. Sorry to. Just give me a moment. Yeah, sorry guys, sorry for the interruptions. So if I'm talking about the CCD, CCD is actually stands for charge coupled device, right? So CCD stands for charge coupled device. If I can specifically tell you in the battery manufacturing, CCD inspection machine is the high precision industrial vision system that actually uses the cameras, that uses the lighting system, that uses the image processing software, and sometimes it is utilizing the AI based algorithm basically to inspect the battery cells and pack assembly quality automatically. In EV battery manufacturing, thousands of cells and weld points exist inside a single battery, right? What do we mean by the weld point? This is one weld point. You can see. Likewise, they are doing the weld point. So this is one weld point. This is another weld point. Third, fourth, 5, 6, 7, 8. So this is a 48 volt and 12 ampere hour battery pack, right? So in bigger it is 60 ampere hour, 100 ampere hours battery pack. So you can find how much weld points are being there. So physically checking them or manually checking them, it is very, very impossible to check them with higher accuracy. That is the reason I told you that in EV battery manufacturing, thousands of cells have multiple weld points, lot of weld points, thousands of weld points exist inside a single battery pack. And that is why the manual inspection is almost impossible with high accuracy. Therefore, the CCD system acts as an eyes of the automated production line, and these systems continuously capture high resolution images during the manufacturing and compare them with the predefined standard, right? So the machine checks battery cell dimension, polarity orientation, weld quality, alignment accuracy, any kind of missing component, insulation placement, and assemble defect in the real time. And since EV batteries, operate on high voltage and high current, even a very small manufacturing defect can later become a serious safety issue. And that is the main purpose of, this CCD inspection device, to improve the manufacturing accuracy and reduce human error, such that zero defect production can be happened. And in automated battery lines, assembly lines, CCD systems are integrated directly with the robotic welding stations, conveyor systems, and the PLC controller, right? And if camera detect any abnormality such as incorrect weld position, missing nickel strip, or damaged insulated rings, or dimensional mismatch, if some cell will goes up, some cell will goes down, and spot welding is coming down, the system immediately flags a defect or stop the production line. Production consistency basically, and prevent any kind of defective battery pack from reaching to customers. So modern EV battery pack factories, if I'm talking about, they're utilizing the CCD systems, which is called to be as a charge coupled device system. because battery pack require an extremely high tolerance, especially during the cell placement, spot welding, laser welding, module assembly process, and without CCD inspection, defect may remain hidden and later cause the overheating, pack imbalance. Apart from that, overheating, short circuit, thermal runaway inside of vehicles. Right. So that is the reason why this particular CCD in battery production. This you can see in the middle. You'll find a CCD machine which is being placed. You can just place the battery pack over here. It will have a multiple cameras. It will use the AI-enabled, algorithms which will use the image processing software, lighting systems, cameras, and ultimately detect all the things that have not been normal. Right. So this is a CCD inspection in the spot welding area. You can see how a CCD inspection is being happening. You can see the image code. Right. So they are properly coded. Fine. So these are the multiple inspection process: cell position detection, polarity inspection, weld inspection, bus bar alignment, dimension measurement, right? Surface detection, adhesive verification, barcode QR scanning, connector inspection, foreign particle detection. We're going to do that. Right. Then we have something called to be as a CV sensing, wire connections. Right. So once the complete thing is been qualified, that means you had do the spot welding. Once you did the spot welding, then you will do all the. Once you did the spot welding, then you can able to perform the CCD testing. Once the CCD testing is being done, then you are going to pass this particular battery pack to the BMS unit. Those BMS unit will going to integrate the BMS, but prior to integration of the BMS, you have to connect the CV sensing wire basically. CV sensing wire is the voltage sensing wire, and those wire need to be connected to the BMS particularly. For example, if you have a 15S battery management system, or if you have a 15 cells connected in a series, so you have to use the 15S battery management system, right? And that 15S battery management system has 15 plus 1 wire, that is called as 16 wires is in there, right? So that is called to be a CV sensing wire. If I can showcase you, you can see this is the CV sensing wire, right? You can see this is a 17 battery management system. This is 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, and 17. How many wires are being there? 17 wires are being there. But how many black wire is being there? 1 black wire and 16 red wires are actually being there. So this 16 red wires is nothing but called to be as 16 series cells need to be connected, and 1 black wire is actually being there. So generally, if I'm talking about the sensing wire, typical sensing wire configuration is nothing but called to be as N plus 1. So how many sensing wire is being there? N plus 1. N is the number of cells connected in series. How many cells connected in series? 15 cells. So 15 cells plus 1, it is nothing but 16S. So sorry, 16 sensing wires are being there. And this is nothing but a 15S BMS. So in a 15S BMS, 16 sensing wires are actually being there. Right? Out of which 15s are red wire and 1 is black wire. And in the 16S BMS, 17 wires are being there. That means 16 red wire and 1 black wire. So you have to properly do this particular thing, right? So that is the reason why I had given you the formula in here. So it is 16S battery pack. You will having a N series plus 1, 16 plus 1 and 17 cells. So there is an assembly unit which is called to be as a CV sensing wire assembly unit. So where the sensing wires is actually been connected to the battery pack, and they need to be properly connected. Once you're going to connect the sensing wire to the battery pack, this is the BMS you can see. So this sensing wire is actually been going into here. Here was this particular BMS, and you can watch this particular BMS. This sensing wire is actually been connected over here, right? And here you will find a MOSFET has been present, right? So this sensing wire is actually been connected over here. This sensing wire is actually it is called as the voltage sensing wire. Right, and here you will find a lot of voltage sensing unit is actually been placed. A lot of voltage for each cell, you will find each voltage sensing unit, and that voltage sensing unit is nothing but it is an IC basically, which has been present inside a battery management system. If we will open this particular battery management system, we will find an IC. That IC is having 17 wire, and that IC will having a multiplexer and a voltage sensing things will be there. And that IC is being manufactured by multiple companies like Texas Instrument, like Analog Devices. So these are multiple companies who are manufacturing the voltage sensing ICs, and these sensors are being placed over here embeddedly, and they are causing the wire to be PMO. Right. The black wire is yes. The black wire is actually stands for negative, not 0 volt. It is negative. Right. It is connected to the negative of the pack, and remaining red wire will be connected to each string. Right. If I'm saying that it is a 16S BMS, it is a 16S BMS, so it is a 16 string BMS, not series BMS. It's a 16 string BMS. And you can now you have a question, sir. What is this? This is nothing but called to be as a temperature sensor. Basically, this sensor is having, you can see thermistor over here, right? Basically, the thermistor is being present over here, and this is the temperature sensing wire, and this is NTC. NTC stands for negative temperature coefficient. Negative temperature coefficient means if temperature increases, resistance increases. That is why it is called as NTC. If temperature increases, resistance decreases. That is why it is called as NTC. In the cell internal, you will find a PTC sensors, right? PTC stands for positive temperature, right? So once you had connected a cells with the voltage sensing wires. Just give me a moment, please. Okay. Once we are going to connect the voltage sensing wires with the particular pack, then we have to properly test whether whatever the wire we are connected, it is properly connected or not. If the voltage sensing wire has been connected abruptly, so your BMS will not going to work, right? It will not going to work. At the output, you will not going to get any kind of value, right? So that is the reason why you will require this kind of machine. This is called to be as a BMS quick tester. So once you had connected the cells, wires with the battery pack, then what you will do, you are watching this particular voltage sensing wire. You can just place the voltage sensing wire over here in this particular way. And if you place the voltage sensing wire over here, it will showcase you certain values. And by reading those values, we can able to understand that yes, your voltage sensing wire is properly connected to the cell. Now you can connect the cell to the battery pack. But prior to connect a battery pack, just remember whenever we are charging or discharging the particular cell, right? See, what is happening whenever we will test the capacity, first we're going to charge the cell, then we're going to discharge the cell, then we are getting the capacity of a particular cell, right? If we're going to discharge the cell, what will be happen? The cell is getting discharged. Once the cell is getting completely discharged, means it is very lesser voltage is been there, 2.8 volt, 3.2 volt. Likewise, the cell voltage are being there. So some cell voltage is 2.8 volt, some cell voltage is 2.9 volt, some having 3 volt, some having 2.8 volt. So what we need to do, we need to equalize this particular cell voltage, and that is nothing but called to be as a cell balancing. Right. So that is the reason why first, before testing the complete battery pack, there is a one remaining thing is been there. We need to equalize the pack voltage basically. So for them, we need to connect it to the cell balancer. So this is the cell balancer. This is called to be as an active cell balancer, right? And this active cell balancer will going to balance the cell by using the capacitor bank, right? So there is another kind of cell balancer which is called to be as a passive cell balancer. Basically, in active cell balancing, your voltage, your higher value voltage is been transferred to the lower cell. But in a passive cell balancing, those who have higher value of voltage, that voltage is actually getting dissipated. So this is a lithium-ion battery pack, balancing unit. So before testing the pack into a real, testing machine, you have to first balance those cells over here. Once the cell is being balanced, then you can take those battery pack to be tested in the other end. Right. Then once the cell is being properly balanced, you can mount the battery management system. You can paste the epoxy sheet, and you can do the shelving process. In the shelving process, we are attaching the barcode, we are attaching the QR, so that we can able to trace that particular battery pack. We are writing the adversaries that any kind of damage or displacement won't happen. And then our complete battery pack has been manufactured. So this is how our battery pack has been looking like. And in the shielding, we are actually keeping this particular thing inside a casing, and we have to seal it. And outer of that casing, we have to put the QR process. So this is a cell to pack approach. You can see this is a cell to pack approach. And if I'm talking about this is cell to module to pack, CMP approach. Right. So this is how it is being manufactured. Even if I'm talking about a module is being manufactured like this, you can see these here present. These are 4-wheeler. So this is present, which is called to be as a battery disconnect unit, right? Battery disconnect unit, right? BDO, which we are calling, or sometime it is called to be as a high voltage safety interlock, HVIN, right? So it is connected of fuse, it is connected of lot of contactors, high fast chargers, thermal management contactors, pyro fuse, aerosol sensors, all those things are being connected over here. And you can find this is the thermal cooling chambers as I know. Basically, thermally, all the coolant will pass over here and absorbing heat from the back. Right. So you can see next we will go for, once you will manufacture the battery pack, then you have to sell those battery pack in the market. For that, you have to, perform the homologation process. You have to certify that particular battery pack, right? So for certification of that battery pack, you have multiple things. If you are certifying the EV battery pack, you have AIS 156 and AIS 038 standards. If you wanted to certify portable lithium ion pack, you have Bureau of Indian Standards IS 16046. If you wanted to certify a export shipment, means if you wanted to sell those particular things to outer states or outer countries, you have United Laboratories 38.3 things. If you're utilizing it for industrial and ESS, you have IEC, Indian International Electrochemical Commission 62619. Cell certification have IEC 62133, IS 16026. Then if you wanted to use those cell as vehicle for approval, you have to go for Central Motor Vehicle Regulation homologation, and global market have this certification things are with there. And who are the certifying agencies, who are the authorities who are involved in this particular certification process? These are the authorities who are being, one is BIS, then ARAI, which is utilizing EV battery testing and homologation, then ICAT, which is there in Manesar, right? Central Institute of Road Transport, which is CIRT, right? Which is used for bus and EV validation. Then there are multiple CMVR rules. These follow, means ARAI, ICAT, CIRT and NETRAX, which is there in Indore, right? So they are actually basically the certifying agencies who are going to certify your particular, right? So this is the process of a battery pack homologation basically. First of all, you need to identify that which vehicle category battery pack your developed battery pack belongs to, because different regulation apply for different vehicle classes. In India, L category vehicles are called to be some motorcycles, scooters, auto rickshaw. M category is the passenger cars. N category is the commercial vehicles, right? For example, Ola scooter EV battery. So you have to go for an AIS 156 is applicable for Ola scooter. Tata Nexon EV battery, you cannot go for AIS. You can go for AIS 038 applicable, right? So this step is important, which is nothing but called to be identify the battery category, because based on your battery category, your test procedure, differ, right? For example, let us suppose I had also see some of the manufacturers, what they are doing. They are, while doing the registration, they told it is being used for the two-wheeler. Then once it has been going into the testing process, they are saying it has been used in the three-wheeler. So suddenly the certifying agency will going to cancel the homologation process. Why? Because if you at the registration time, whatever you are going to fill up, test can need to be certified, because they are going to arrange the test likewise, right? Because every test process is different, because every batteries have different thermal propagation rules. Every batteries have different abuse test limit. So it will be changed depending on the vehicle category. Then you're going to identify the authority, right? Once you identify the battery category, you're going to find the authority, that from which authority you want the things. There are 5 authority which is being present. One is ARAI, Automotive Testing and Certification. They are going to give ICAT, which is in Manesar. ARAI is in Pune, which is going to give you the vehicle battery and homologation. CIRT is in there, Automotive Research and Testing. GARC is doing there, which is used for vehicle certification specifically, but GARC I might not thought it is there for battery pack. And NATRAX is being there, which is again go for automotive proving and validation. Then you can go for IIT Delhi's. IIT Delhi's are utilizing the NATRAX certifications while implementing it. Right? So, so then once you had identified the authorities, then you have to freeze your design basically, right? Freeze your design means this is the most important industrial stage. Your design freeze. Freeze means no further major design changes allowed. See, if it's certified for one design and if you small change the design, you have to again apply for the certification. That's why while applying for the certification, you have to freeze the design. There is an option to freeze the design because beyond that, no further major design challenges allowed or changes is allowed. So at this stage, cell chemistry need to be properly finalized. Battery structure need to be properly finalized. BMS logic need to be properly finalized. Cooling system need to be properly finalized. Fuse and contactors need to be properly finalized. Enclosures need to be properly finalized because once homologation testing starts at the authority center like ARAI, NATREX or ICAT, changing design means you have to again retesting, you have to apply again the same process from the very front. And again, it will require additional cost and delay in the approvals, right? Then we have something called to as a document preparation. Now the manufacturers will going to prepare a complete technical documentation like battery pack drawing, their mechanical layout, their electrical schematics like high voltage and low voltage architecture, the BMS logic, whatever they had been utilized, the thermal design report like cooling validation, the IP protection report like ingress protection of water and dust, the FEMA report that is the failure analysis, right? I hope those who are belongs from the mechanical engineering background, they might have know what is FMEA, failure analysis, right? Is being there. So then we have something called as BOM. We have to submit the bill of materials. Then we have to submit the safety concept documents, which basically consist of hazard mitigations, right? Once that documentation has been done, why this documentation is extremely important, they will going to this, the documentation is extremely important because certifying agencies validate the traceability, component rating, safety logic, and compliance strategy basically. And if they will find any abnormalities in that, they will not going to certify your particular pack. And then we have cell level certification system there. That means before pack testing, individual cell themselves already been certified, right? Because if let us suppose I had purchased the cell or I had only manufactured the cell, then from my manufactured cell I have prepared the battery pack, then I have to certify my cells as well. So cell manufacturers will usually provide UN P8.P report, IEC test report, safety consideration report. So I have to attach that thing with the cell level certification as well. Because if cells themselves are unsafe, how we can claim the pack level safety? It is become impossible, right? Then we have to perform the UN P8.3 testing, right? That is mandatory for transportation safety. And without UN P8.3 safety, battery cannot legally be shipped by air, by sea, or by road internationally. For example, if I don't have UN P8.3 testing certificate, I cannot ship the battery by road or by air or by ship, right? So basically, in UN 380.3 test, it is actually testing the altitude simulation, air transport safety. It is not happen like if you transport your pack from air and your battery pack will burn, so aeroplane will going to be damaged, right? So aeroplane will again going to be burned and life of someone will be in the stakes, right? So that is the reason why altitude simulations need to be done. Then we have thermal cycling, which where the temperature resistance must be checked, vibration, shock, external short circuited parameter, impact on crush, overcharge, force discharge, all those things are properly been checked. For example, suppose you are shipping a battery from China to India without UN 38.3, customs clearance may fail. So customs will not going to allow you to ship that thing. Those who wanted to do this business on this, so they can go for this. Then we have AIS 156 and AIS 038 testing, where the main Indian batteries, safety standards is being there. After EV fire incidents, all India automotive industry standards become much stricter, right? So once that is been done, then we can go for BMS validation part. Then in BMS validation, basically the battery management system is being validated. Whatever electronic circuit had been used, the BMS is being tested for voltage monitoring, current sensing, temperature sensing, fault detection, contactor controls, balancing, communications, fail-safe operations. They are being tested for that, right?
Suppose one cell voltage rises dangerously and PMS must detect that fault and stop charging and isolate the complete battery pack safely. And without proper BMS, possible risk is being there of overcharge, cell swelling, fire, and thermal runaway, right? Then we can use the thermal runaway analysis method, in which is very, very important as far as EV fire incident in India is concerned. So this test will going to check how a battery will behave during the cell failure. Basically, this test has been done to ensure the passenger safety and passenger getting warning if their battery pack is been getting heated and thermal propagation get delayed and vehicle evacuation basically. Right. So this test is basically concerned that nail penetration test, overheating test, external heating test, and internal short circuiting test. Then we will do the EMC and EMI testing. EMC and EMI testing on EV battery and BMS will going to produce the electromagnetic noise, and this testing will going to ensure that battery do not interfere with motor controller, sensors, and other communication and infotainment system which is being present inside the vehicle as well as the vehicle electronics. EMC is actually stands for electromagnetic compatibility and EMI stands for electromagnetic interference. So this test is very, very important test as far as battery is concerned. Right. Then we have environmental test where the battery pack is tested under the extreme environmental conditions like humidity, dust, water space, salt fog, thermal cyclings where the expansion and contraction will going to happen. So over there it has been done. Then we have something called to be as sample submissions. In the sample submissions, basically the manufacturers will going to submit the battery samples, documents, BMS firmware, softwares, test data to certified agencies such that this test data will be properly analyzed by the certified agency and they will going to certify your battery pack. Then we can go for testing labs where the authorized testing laboratory will perform all the validations in India's major labs like ARAI, ICAT, JARC, NATRAX, CIRT, and last we have test failure. If the battery fails any kind of test, redesign is being required and root cause analysis need to be performed, which is again done by that FMEA method. And again, you need to perform a corrective action which has been implemented and then you again send for the retesting. Right? Suppose a battery fails a vibration test because of weld crack developed, the company need to redesign the bus bar support, foam compression and mounting brackets basically. And after redesign, they need to again repeat that complete testing. And once it has been done, then your final homologation has been done, which is after all tests has been passed, agency review the report, document compliance, data and safety validation, and final homologation approval is granted. And then last one is the CMVR approval and homologation certificate. Now official homologation certificate is issued under the CMVR, Central Motor Vehicle Regulation Act, and this allow the legal sale of vehicle battery in India. And without CMVR approval, a vehicle cannot legally operated on the public road, not even the batteries as well. Right? Guys, just let me complete. We'll discuss on this thing. Then we have BIS certification. Some battery product may additionally require BIS certification depending on applications, import component, regulatory category based on that. Right. So once it has been done, the compliance with standard will going to ensure the safety, reliability, and legal market access. And then this is called to be as a ingress protections. Actually, what kind of month this particular total thing will going to take? It will generally going to take 4 months to 12 months of time. If I'm talking about if you have the electrical failures basically, right? So it will going to take 4 months to 12 months. And generally, if a manufacturer going for the bigger packs, then 3 lakhs to 15 lakhs for UMP 8.8 testing. Different money is being indulged in this particular, right? Now you will ask me, sir, 3 lakhs to 15 lakhs, if we go for an homologation, why the cost is so high? Because multiple destructive tests are actually been required on your battery. Sometimes what happen, you will send some sample to the ARAI, they will going to destroy that sample, then they will ask you again send me the sample. So that is actually because while giving the overcurrent, so battery will going to damage. So that will be damaged, that should be recovered, right? So that is something is been multiple destructive test is actually been required. and multiple pack samples are actually get destroyed, and that is the reason why there is redesign may occur, lab charges are high, engineering manpower are required, then documentation effort is again very high, then your pack is being certified. So that is the reason why they are basically right. Then there is something called as IP ratings, guys. IP is actually stands for in-place protections, and basically if I'm talking about I stands for in-place, then it stands for E stands for protection. It is a rating system which is used to define, how it is the rating system which is used to define how well, an electrical enclosure or a battery pack is protected against any kind of solid particles like dust, powders, and any kind of liquid erasers like waters, right? So IP rating is extremely important as far as battery pack is concerned. As far as EV is being operated, it is also tested homologations as well, and every pack need to be confirmed with IP67 rating specific, right? So if I'm talking about IP, it is written IP rating is written like IP67 or IP68. So the first digit, that is 6, will actually represent the protection against solid object, which is nothing but fault pressure dust. Then we have the second digit, which is representing the protection against liquid and water. If I'm talking about IP67, so first digit 6 means completely dust tight, means no dust can able to enter. So no dust can enter into the enclosure. Second means 7 means protected against temporary water immersion. Usually 1 meter of depth for 30 minutes, no water can able to enter into this. So basically, your IP67 is mandate for major electric vehicle. Even you are manufacturing a small electric vehicles, IP67 is the minimum requirement for the pack is right. So now, if I'm talking about these are the electric cart, battery pack designs are being there, where motor is being powered, where the motor have 3 to 5 kilowatts. So generally, this has been best practices as far as I had saw the go-karts basically. So if the motor is being powered between 3 to 5 kilowatt, so the battery voltage is 48 volt to 72 volt, and capacity may be vary from 30 to 60 ampere hour based on what you are basically utilizing, right? And approximate pack power is 4 to 6 kilowatt hour. And if you're used for amateur racing kart, if you'll go for a student EV kart, that will be fine. And if you'll go for an amateur racing kart like Formula Champions likewise, or even higher than that, then you can go for 8 to 12 kilowatt motor, 72 volt battery pack, and battery capacity must be 60 to 100 ampere hour and 6 to 8 kilowatt. Professional racing kart have 12 to 25 kilowatt motor is being there, so 96 volt battery, and capacity may be vary from 80 to 150 ampere hour. So maximum, I had saw 150 ampere hour is been going as far as go-kart is been concerned. Never go for 160 ampere hour. Likewise, maximum 150 is enough for go-kart applications is been concerned. So it is 8 to 15 kilowatt hour battery is being there, right? How you are calculating the kilowatt hour? Simply will multiply 48 by 30, you will getting something in watt hour, then you have to convert them into kilowatt hour. That's simple, right? So this is how these are the various things which has been utilized, and this is a typical battery configuration. A typical racing kart pack is chemistry. It is utilizing NMC and LFP. Voltage it is utilizing 72, and configuration might be 20S. Okay, and capacity will be varied in 60 ampere hour. This is one of the ideal I am showing, right? And it will vary depending on multiple things, whatever you had utilized, depending on the design of your chassis, depending on the motor selections. This thing will be vary. I'm just giving you the ideal things what I had saw majority of the competitors has been made through. Energy is 4.3 kilowatt hour, and the continuous current what they can able to provide is 150 amps to 200 amps, and the peak current they can able to provide 300 amps to 400 amps. And basically in the go-kart we are utilizing the air cooled system. We are not allowed to use the liquid cooling systems. And BMS is smart CAN bus BMS, and protection must include this fuse contactor and pre-charge protections must be there, right? So you must have a charger, and inside that charger also you had connected a fuse, right? Contactors assembly, battery disconnect unit is must for safety purposes. Battery disconnect system is must. So this has actually been tested by the judgmental round. Basically, they are going to test whether this
things are actually been there, or these things are actually been placed by you. So they are actually going to test all those parameters as well, as far as battery is concerned, right? So these things are being there inside the PPTs, guys. I hope you had get some things. But apart from that, if I go for a certifications, basically, if you are asked about, I will come to this AIA 007 certifications as well. See, if I'm talking about, we will go to any certifying agency and we will ask them to do the test. So they will generally going to perform the 13 test. One is vibration test they will going to perform. Another test is the mechanical shock test they will going to perform. Then dropback impact test they will going to perform. They will going to perform the thermal shock and thermal cycling test where where the test will going to evaluate how battery will behave under the rapid temperature change conditions. They will going to perform a fire resistance and thermal propagation test. They will going to perform a water and dust resistance test, which is called to be as an IP test. They will going to perform an overcharge protection test, right? Where they will going to overcharge your particular battery pack and they will see whether your BMS can able to protect it or not. They will going to perform over discharging protection test. They will going to perform over current protection test, and they will also going to perform over temperature protection test as well. Then short circuit protection test, which is a part of an overcurrent protection, right? And for that, you must have to connect a pyro fuse inside your modules. If you're utilizing a module to pack approach, you have to use a pyro fuse basically, right? Then they will going to perform isolation resistance test as well. This is one of the most important high voltage safety test. Most important isolation resistance test. This test will going to check the isolation between a high voltage battery terminals and the vehicle chassis body basically. And poor isolation can cause to electric shock, leakage current, insulation breakdown, and high voltage safety hazard. So that is the system which will going to measure the insulation resistance typically in mega ohms. And an instrument which is coming, it is called to be as a Megger. So Megger is something this which is used to calculate this thing, right? And if the insulation drops below safe limit, BMS will going to trigger the fault and vehicle shutdown may occur. And this test is critical because EV battery pack operate at 48, 72, 300 volt, 800 volt or in higher voltage. Even we are working on 1000 volt architectures as well, right? So these are the 13 tests which the, basically the, conduction, which the authorities are actually conducting, and ultimately that will make your battery pack more safer onto that, right? So this is from my side, guys. If anyone have any doubt, you can please do let me know. Anyone have any doubts this particular things? Yeah. Wait. Just give me a minute. Yeah, Swapnil, you can ask.
Hello.
Yeah, Swapnil.
Sir, you have talk about the cylindrical cell and prismatic cell. Especially in go-kart, what type of battery cell we should use, or any recommendation?
You can generally go, yeah, you can generally go for the cylindrical one if you can take my suggestions. Prismatic will be a bit heavier actually for the go-kart.
Okay, and what about the pouch cell battery?
You can use the pouch cell again. That is good for your pack, but but for pouch cell you have to taken care of all the cells. Cell to cell have a proper insulations, right? And manufacturing a pouch cell based battery pack is again going to follow that geometrical approach of cell to chassis manufacturing, right? Again, if you'll use a separate casing for that, that is again good for if you're utilizing a pouch cell. But see, advantages of utilizing a pouch shape is that if you utilize a pouch shape, then if there will be any kind of thermal things will going to happen or thermal propagation will be happen. Pouch cell has something called to be an expansion area, right? Okay. But preparing a casing for a pouch cell is bit a typical challenge for everyone. Okay. So that is the reason pouch cell manufacturing it is good, but it is bit complex as far as go-kart is concerned. Not even go-kart, for the normal battery pack, again it is different. Right, that's why you can see cylindrical and prismatic more on, but nowadays companies are opting for a pouch cell as well.
Yes, yes, yes. But the major concern is manufacturing point of view, right?
Exactly, manufacturing, you want a proper smaller spot welding machine, electrical spot welding machine, you have to properly spot weld it, and even the smaller rush current will going to swell the pouch cell basically, right? So that is one concern in the pouch cell. That's why people are going for a nickel cell. But almost pouch cell will going to give you, good kind of energy density as well as power.
Okay, okay. Thank you, sir.
Yeah, and a doubt from Nina Palkar.
Hello.
Yeah.
We, in one of the slide, we saw that several protections that we have to use. That was regarding fuse, contactors, and all. My question.
Yeah, can you please repeat again? Yeah.
Hello, am I audible?
Yeah, you are audible now.
Yes, yes. So considering the safety when installing a battery pack and overall safety of an vehicle, so generally we use contactors and fuse, right? But assume a scenario, I have a closed vehicle. Right, I have closed vehicle. Entire my whole traction system is within an enclosure. You can say within the what you can say roof of the car. So the internal temperatures are going to be hot, considering it is solar vehicle and so on. So what typical margin that we have to consider choosing our protective equipment? So let's say I have a battery of peak discharge of 2C, right? Consider it's a 100 Ah battery and it has a peak discharge of 2C. So it gives roughly around 200 amps maximum. So what is the margin that I have to consider when choosing appropriate safety ratings of fuse and contactor? Right? I cannot directly use an 200 amps contactor fuse, right? Because inside the temperatures are getting higher. So all my equipment is there, they are going to get derated, right? So what is the general margin that is considered in the industry? That if we have this particular amperage or ampere usage, we have to use just a slightly higher fuse. So what is certain margin that we are considering?
See, actually what is happening, that margin whatever you are asking about, that is depend upon your testing parameters. For example, somehow if I tested my particular pack inside, for example, I tested my particular cell inside a cell testing machine, and I had over abused a bit. Abuse shipments, for example, in specifications it was written I can able to give him 1C rate, but in the specification sheet it is written on the basis of their testing. That is not, you cannot charge it at 1.5C, you cannot charge it at 2C. Right. So 1.5C to 2C, if you're going to provide a current to that particular cell, that will going to work wrong. Right. But there is a margin of error that the temperature will going to rise. Right. Now I have to be assured that how much temperature is actually rising in that particular cell. For example, I had tested few days back a cell it is actually made from China. So I had tested the cell in our test cell grading machine, and I had tested this. He had taken that maximum you can test at 1.5C, but I had tested at 3C. It had been properly worked, but whenever I'm tested at 3C, I'm giving a pulse current to that particular cell for 3C. Temperature is actually going to be increased, right? Then what had happened, the battery will actually cut off and temperature is go beyond 40-45 degrees Celsius. This, I'm talking about a cell, I'm not talking about a pack, I'm talking about a cell. So if the temperature at a 2.5C if I'm charging, and if it is go beyond 40 degrees Celsius, so I have to look onto that Excel sheet that at which point it will going to be shoot up. So that particular time I need to check what is the margin of current which is being flowing inside a particular cell. So at that time, I need to use that much more. For example, let us suppose at 200 amp, let us suppose at 5 ampere, let us suppose I'm utilizing a 6Ah cell. So I am utilizing it at 18 ampere of current I am flowing through that particular cell. And I had say that when the 12.5 ampere, not able 12.5, we can say at 13 ampere or something around 13.5 ampere, I see the temperature of a battery is being raised to 40 degrees Celsius. You won't believe the BMS, the machine will cut off the machine had cut off the things from that. So my process will be stopped in the middle. Else that time huge accident may happen, right? Because BMS is being also present inside that machine, which will going to check the battery temperature of that particular thing, and that battery is really hot. So I find out that if I'm going to give 13 ampere of current for nearly around 2 seconds or 3 seconds, the battery temperature will going to shoot up in a linear fashion. Based on that, I will going to use the 13 ampere pyro fuse inside a particular cell, such that it will not going to hamper my circuit or hamper my battery. So if you will ask me particularly that there is any specific tolerance value is being followed by the industry, so I will let you know that they are not following any tolerance value. Even in the internet, you will find 5 plus minus 5% tolerance value, plus minus 10% tolerance value. But I will let you know they are actually testing the cells at different conditions. Based on that, they are calculating that at what current the battery pack temperature is being heighting. And based on that, they are utilizing the fuses accordingly. For example, if I'm talking about, there is a Tata Tiago battery pack where they are utilizing a 320 volt battery pack, right? And that battery pack is being utilized inside the Tata Tiago, vehicle unit. There is a fuse which has been connected in the fast charging, which can able to charge the battery pack at nearly around 210 or something likewise ampere. They had connected nearly around 230 ampere fuse over there. In case of slow charging, not even slow charging, in case of the battery output, they had connected nearly around 250 ampere, fuse basically. So the question is, they had not considered that tolerance value for that. Just they had tested that particular system at the different C rate, and by the data they had calculated that this fuse need to be embedded. Because if I'll ask you that if we'll take a tolerance value, 99.9% of time, what will be happen? Let us suppose you had taken a tolerance of 10% and you had connected a fuse. And once you will connect it in the internet, you will find 10% or 5% tolerance band. And once you will connected a fuse accordingly, it might happen that before your battery performance, your fuse may drop, or it might happen your fuse cannot able to withdraw that particular thing and it may drop, or it may cut off the supply. So your battery performance won't able to come, right? So you will find a multiple time your fuse may trips, and that is actually happened with me whenever we are designing a battery pack for our normal, a vehicle, a two-wheeler. So we had taken a plus minus 5% or plus minus 10% of the tolerance for a particular fuse, and that fuse will going to trip, or basically that fuse will going to burn. The filament inside a fuse will going to burn after every current will be, if you're going to run the vehicle at full throttle, sometime what happens, the fuse will burn. So the customer come to us, he will complain to us that my fuse will going to burn in like that. Actually, this is he had given us a vehicle to make it as an IC engine vehicle. We have to make it on an electric vehicle. So he'll complaining me that every time my fuse will going to trips. So why it has been tripped? Once we'll check that particular battery pack. So the battery pack tolerance is different, but the fuse is actually tripping in some different manner basically. So if I'll ask you, according to the papers, you will be go through the paper, they will be getting plus minus 10% of a tolerance band or 5% of a tolerance band. In somewhere it is going around plus minus 2% of a tolerance band as well. But actually it is depending upon your testing well. Right. So always it is recommended that based on the testing only you can, that will be more utilizable. Right. And again, you will not going to face any kind of homologation issues whenever you are sending your battery pack to the testing agents, because they will going to abuse your battery pack, and if smaller fault will be happen, you have to complete the processing. I hope I can able to clear your
Yes.
right. So there is no yeah, Shlok, you have any doubt?
Hello, sir. Actually, I wanted to know what the thickness of nickel bus bars or nickel strips should we use for our battery.
You are asking about thickness of a nickel strips which has been used in our battery pack. Actually, wait, I got you. Wait. Actually, I had that particular slide, or I had skipped it. Just give me a moment. Actually, I had skipped. I don't add that particular slide. Okay, fine. Just give me a moment. Actually, that slide is not been added. Fine. That's why I'll skip. Apologies for the same. Basically, it is depend upon your current capacity, if I'm not wrong, right? So let us suppose you are working on 5 to 7 ampere current, then 0.15 mm thickness is actually been required, which is being used for e-bikes or moderate current kind of vehicles. And if you're utilizing 7 to 10 ampere of current, then 0.20 mm is been required. If you're used for racing and high performance packs, you can go for 10 to 15 ampere, if you are utilizing that. So for that 0.25 mm is been required. Again, if I'm going for more than that, like 15 to 20 ampere, which is a very high current bus connections, there 0.30 mm is required. Generally, in the battery pack which we are utilizing and what I had showed to you, that is 0.15 ampere basically, which is utilized for that. And the smaller electronics, which is for the pouch cells, they are utilizing 0.10 mm. So different current having something different. Actually, I had not embedded that thing. Actually, I had a table, but I had not inserted inside this. So it is based on the current. So if you're utilizing it for e-bike, so 5 to 7 ampere it is there. So you can go for 0.15 mm basically, right? So current is actually depend upon the width and the material basically. And again, standard widths for, if I'm talking about 18650 cells, it is, you can find in 6 mm kind of things will be there. For LFP cell, it is slighter higher is being there, where you will find a pure nickel strips, which is having nearly around 8 mm strips, which is being present over there, right? So that is something is being there. I had forgotten to add that PPT. Just give me a moment. Actually, that particular slide is in there. Fine, no worries. I will add that particular thing in the PPT and I will share it out if it is allowed, because that thing is get forgotten, I guess. I had added that thing. I will share it to you. Right?
Okay, sir. Thank you.
Yeah. I had that particular slide. I'll share it to you. Rajesh sir, is the PPT is allowance sharing is allowed or?
So actually, the video is already there. Like a student can like watch. It's
Okay,
available
actually,
on YouTube. You
uh,
can just
yes.
send a screenshot or like a picture if anything is
Yeah,
missing.
I will share the screenshot, that thickness screenshot of a bus bars or nickel strips. So you can just send them, sir. That will be better.
Okay.
गुड आफ्टरनून
So,
सर
good afternoon.
सर वो सर्टिफिकेट की लिंक मैं वो कर नहीं पाया सर थोड़ी नेट स्लो हो गया था
Okay. So good evening everyone, and thank you for joining. So I have already shared like some links. So you have to fill that for the certificate. That is basically for attendance. And apart from that, as you know, we have ISA India. Apart from these trainings, events and all, we are running some courses. That is a master degree program and some internship program is going on. So one of our colleagues, Shivani, is there. She's just going to explain about that. So if anyone interested to opt like any internship program or any course which is running by ISA India, you can opt that. And I have already shared like a Google form to fill for the certificate. You just have to fill. Your certificate will be prepared according to that. And once you will get the certificate, I'll suggest just submit. Post those certificate on LinkedIn tagging ISA India. You will get better visibility. And how many are there like from our IKR formula or ESBC event? May I know that? Hello. Hello. Am I audible?
Yes, sir, you are audible. Students had raised their hand.
Okay. So, as you already know, for IKR, the workshop is scheduled on 26th and 27th at Pune at DY Patil. So, you all are welcome to join. And as I already know, so we are running some internship program that is on hybrid and online model. So Shivani, are you there? Hello, Shivani, are you there?
Yes, sir.
So you can just explain about like the internship program. So if anyone will interested, you can fill that Google form. So accordingly, our team will connect you.
Okay, sir. So, hello everyone. I hope you all are doing well. So currently we are offering a summer internship program, which is National Electric Vehicle Industry Exposure Internship Program. Okay. In this, we have two modes. In mode one, which will be fully online program and live classes will be there 2 hours a day and 5 days a week. Okay. The topics will be for week one, EV basics and vehicle dynamics. For week two, the topic will be battery and motor systems. For week 3, the topic will be power electronics and control.